Ah, vale, ya. Vale, creo que ya. Desactivo el audio, ¿vale?
Okay, should we start? Hello, everybody. It's a pleasure for me to be the chair of today's first session. We have three exciting papers. The first one is on augmented reality, the second one on virtual reality, and the third one is about image compression. The first paper is going to be presented by Karina Rodriguez Chavarria from the Center for Secure, Intelligent, and Usable System at University of Brighton. So please, Karina, the floor is yours.
Thank you. Let me just share my screen. I just remember to. Can you see the presentation now? Yes, can you see it? Okay. So, hello everybody. My name is Karina Rodriguez Echavarria, and I am from the University of Brighton.
But
I'm here.
Karina, sorry to interrupt you, but it is in presenter mode, let's say.
I'm sharing the wrong thing then. 1 second. Let me start again. Slideshow, isn't it? So, can you see now the presentation or the presenter mode?
Yeah.
Now is the presentation, right?
It's okay.
Okay. Okay, so I'm here to present a work we have done in collaboration with my colleague in UCL, Simon Julia, and one of the students, Joaquin Huang in UCL. And I will introduce you the motivations of the research as well as the technical research that was done within the project. Just to introduce you, this research was really looking, I had a really interest in looking at alternative types of access of heritage content. So not your traditional ways in which you would normally perhaps go to a museum and use augmented reality, but I wanted to explore with other types of tangible interfaces. So for instance, I do work with 3D printing, but I wanted to go beyond 3D printing and explore ways in which people might be able to access objects that don't need to be printed and still be able to augment and enhance these physical objects with augmented reality content. So in this case, we were exploring this idea of the pop-up book, because the pop-up book, which is different to the normal books, it has this three-dimensionality, which is very interactive by itself, because the user can manipulate things within the book itself and enable maybe richer ways that people can interact with additional content. So I started looking at the pop-up book as a physical interface for augmenting content. And I realized that actually pop-up books have been around for a very, very long time. Originally, these books were not targeted to children, but were targeted to adults as early as the 14th century. And they were used as a means to provide knowledge, for instance, of anatomy, or in this case, this example here is a book on perspective. So you have this kind of bigger term, which is called movables. That's how they refer to all of these flaps and three-dimensional pop-ups and foldable models that come out from the books. And they indeed allow the user to interact physically and maybe get more information about what is being said in the book. And by itself is somehow some kind of three-dimensional object. So you see here this example. This is a kind of telescopic view of the Great Exhibition in London in 1851. And again, you can see this kind of pop-up is designed for grown-ups and for children. And this is from the Peabody Library. And you can see here you have this expandable, let's say, pamphlet or kind of book in which you have this kind of hole that the user can look at and get this, again, a scene which is three-dimensional itself and describes the opening of the Great Exhibition by Queen Victoria. So it's a really kind of interesting medium to explore, not only as a historical object itself, but as a way that we can potentially augment the objects with content. Okay, so rolling a bit further into the 20th centuries, we see that at some stage, you can see here 1937, the books, the pop-up books became a children kind of target book. So you have these Bucano books, and they were the first kind of books that the user can potentially walk, look around 360 degrees, and you will get these pop-ups that could be viewed from every angle. And indeed, since then, there has been primordially targeted to children. And you have now really, really complex scenes that you can create with this method. So the production of these pop-up books is actually quite complex itself. It's a skill that requires a number of individuals, and you have the person which is called the paper engineer that will take the ideas from an author and an illustrator. These are the two people who would normally be involved in creating the book, but in here the paper engineer is the one that is in charge of creating the three-dimensional aspects of the story, and it's going to tell the story, and it's going to put other things such as motion or action in the scenes. Yeah, so it can get quite complex in terms of what the scene can provide for interactivity. They are also very costly, as they have to be assembled, all these flaps and things that need to be pulled out. They need to be assembled manually. So they are normally kind of produced in other parts of the of the world, and they require a kind of really careful design and production to get to kind of really engaging content. So I wouldn't say that they are incredibly affordable, but I think there is an interest of providing these pop-up books that might be of interest to museums, for instance, and cultural heritage organizations as a means to interact potentially with their digital collections. Okay, just to provide a bit of review on AR. So augmented reality in cultural heritage has been around for many years, 20 years at least, I would say, with some early systems that we were seeing developed for augmenting reconstructions of archaeological sites. And it's an exciting technology because it allows you to mix virtual content with the real world. And you can do this both by doing it in the place, or whether this is in the museum or in the archaeological site, but you can also have some kind of distance engagement with cultural heritage. So whether you are at home before you're going to visit the heritage site, or whether you already have visited and you want to relive something of your visit to that particular heritage site or a museum. Now, since the introduction, I'll say from the AR SDKs before AR Kit and AR Core, this really has lowered the barrier for people to develop AR applications that can be delivered over the phone, and it has been recognized that this innovation in providing access to CH has a lot of potential, for how users might enrich the experience, which is not as isolating, for instance, as providing them a virtual reality headset and have this individual experience. This is a bit more sociable, and you can simply enrich that kind of real experience you are having with the object or with the site. Okay, so again, AR in books, not in pop-up books or in books, there is a lot of work around. So we had some early systems called the Magic Book, where you are enriching, again, the pages of the book with virtual content, and you're allowing interactivity, maybe, or some user control of the content. So you, for instance, in this example here in the top right, you are able to, see this visualization of the coloring a person might have done here for the book itself. So you're able to engage in the physical activity of the book, but you also have some enrichment of content. However, we couldn't find anything in the research that will consider this combination of the 3D physical interactivity with the pop-up books, as well with, with the augmented reality aspect, but maybe exploring this as a means to interact with cultural heritage. So that was the motivation for the project itself. And when we started thinking about this, it was early in the year, and we partnered with the Brighton Museum and Art Gallery and a paper engineering company to design and implement a prototype. And initially, we were playing with the idea of having a historic house, and maybe allowing people to interact or place objects of the collection, three-dimensional contents in this house. But then COVID came, and this really affected our ability to access stuff and heritage items that we might want to digitize, as well as something which was very complex was the ability to co-design something which is a physical output. So I have a lot of experience with trying to co-design maybe something that is 3D printed, but you require a lot of iterations with people and being able to see the physical object. So, the restrictions on meeting physically really had issues for us in being able to all get together and look at some foldable elements that we can think of the pop-up prototype that will be augmented with content. So what we had to do instead was to look for a commercially available book and look at content that was already available, so that we can overcome these difficulties we had during the research. And Simon engaged a master student that would allow us to experiment with that interactivity in augmented reality. The system requirements was to combine the tangible interactivity of the elements of the pop-up book with the virtual content. And we wanted to experiment with accessing some cultural heritage collections by just simply exploring what was available online. And of course, we needed to have previous knowledge of, of the physical elements of the book. Now I have this book here. There's a slide here, but the book is here. And you have this book, which is of London, and you have the three-dimensional scenes, right? So every page has a different kind of landscape or landmark of the city, which we think we can augment with different content of collections. So we selected this scene. You can see it here, which is the London Bridge. And you have this kind of foldable element we have here, which is the 3D model element. This is a more three-dimensional object, but we also have other flaps and objects that can move around and rotate or be open so that you can access more content. Okay, so we did a photogrammetry model. So in this case, we wanted to be able to do things such as being able to align the virtual scene with the digital scene. So we tried, doing, I think we used 160 images and producing the best 3D model we could do, although we had issues around the complexity of the paper foldable model here. And then what I'm going to put you next is a presentation from Joaquin, who is the student that did the development of the prototype. So I will put it and let me know if you can hear it, please.
Hello, everyone. My name is Yaqing Huang. I'm from the CGVI Master Program at UCL. Today, I'm here to demonstrate our AR book application and introduce the technical expansion of this paper. In this paper, we developed an AR pop-up book focusing on precise projection of virtual contents and the interaction between virtual elements and physical components inside the book. One key feature of the AR application is to build a virtual environment in the real world. This is typically achieved by projecting virtual contents on certain images or object targets. One frequent problem we have to face is determining the position and the orientation of virtual contents that we want to project to the real world. Therefore, calibration is a necessary procedure. Many software developed kits can retrieve the position of the image or object targets, but they sometimes did not calibrate the orientation of virtual contents. One limitation of the existing developed tools is that the virtual coordinate system is determined by the initial position and the orientation of device, for example, our phones or tablets, which causes that the orientation of the virtual contents are inconsistent every time we run the application. In this paper, we introduce a calibration approach that makes the projection of virtual contents more precise and invariant to the virtual coordinate system. For the calibration part, we get the position vector by applying image detection. We also assume that the book is placed on a horizontal surface, so we only consider the rotation around the gravity axis. Here, we predefine two image targets in the book and measure the vector between them in the real world. Then, when users run this application again, they are asked to detect these two images again and will get the vector under the current coordinate system. Then the system can compute the angle between these two vectors, which is also the rotation angle of the virtual coordinate system relative to the real-world coordinate system. Therefore, we can make sure that all virtual contents have the right orientation by rotating this angle. Here is the calibration result. We can see the virtual model aligns with the physical book very precisely. After finishing the calibration, users can call out the character by clicking this green indicator. Then users can move this virtual tour guide to explore our virtual features inside this application. When this tour guide attains some desired position, some special effects will be triggered. This is achieved by a collision between virtual elements. After calibration, some invisible colliders are projected at a particular position. Once the collision between the tour guide and the invariable collider happens, special effects are triggered. For example, when the tour guide approaches the ghost book, a ghost pops up, and when the tour guide approaches the castle, a firework displays on the air. Besides, we also adapt object detection for some other effects. Object detections allow us to detect the whole 3D objects instead of 2D images. So we can detect the object and trigger effects from any looking angle. For instance, when the London Tower Bridge model is detected, a video about the history of the bridge shows up. And no matter how we rotate our looking angle, the video is always facing us. We can also observe the corresponding historical images of London Tower Bridge by observing the physical paper bridge from different sides. Another focus of our paper is preserving interaction involving physical movable contents. Different from the other AR books, which only use the books as a trigger for the virtual contents, but in limiting the original 3D model inside the book. In our AR book, we preserve the feature inside the original books and also achieve interaction between physical elements and virtual elements. For instance, inherited from the movable ship model inside the book, we build a virtual ship that users can drive it around. More interestingly, we can detect if the tower bridge is open or closed. The tour guide and the ship can only pass under the bridge if the physical bridge model is open. This is achieved by detecting the height of the bridge elements. Once the bridge is determined as closed, a barrier is activated at the position of the bridge so that the tour guide or the ship cannot pass through it. Furthermore, to gain an immersive AR experience, it is essential to include the real-time occlusion between real-world and virtual objects. Some AR applications use depth detection to manage this functionality. However, we use traditional geometry measurement and determine whether the virtual guide is occluded by calculating the angle and the distance between real objects and the virtual guide. Furthermore, we apply human body detection supported by the Air Foundation to achieve the occlusion between the finger and the virtual guide. In this paper, we emphasize precise calibration and physical model preserve the interactions. The techniques are not limited to pop-up books, but can also be extended to AR technology in other things. We believe our work can inspire further searches in AR for cultural heritage. And thanks for your listening.
Okay, I just
Hello,
want to,
everyone.
oops, I want to just quickly just conclude. And we did manage to get some feedback from users, and it was really hard to get that kind of feedback because we couldn't deploy necessarily the application. But I think that beside the suggestions to improve, such as adding sound, being able to have a more varied interaction, there was really positive feedbacks in terms of what how a user-friendly means this could be to potentially access or interact with different kind of content. With regards with further work, I think the prototype has demonstrated potential to engage new audiences, where this is young audiences, but most importantly, maybe people that would not normally walk into a museum and be able to access cultural heritage material from collections or from spaces in the museum. But further work for sure is required to have this kind of accuracy in terms of the mapping and the interaction with the physical objects, both for occlusions and for the light in itself. And another area that really is, really interesting for us is to allow the user to build potentially their own stories by accessing content from a museum and the accessibility of the experience. So whether we can potentially deploy on things that might be more accessible for a user by just clicking into a browser and being able to access the application itself. And that's it for me. Thank you very much. And I'll be happy to answer any questions.
Thanks a lot, Karina. I really like this combination of tangible and interaction with the augmented objects. So we already have some comments and questions in the panel. So Michela Mortara comments that one of the images was from Game of Thrones. Okay. So Salvatore Mauro asked, could you develop this methodology with any typology of a scenario?
I will need to understand what they mean with the typology of scenario, but I guess you can develop the same methodology with any physical scene, because this is like a mini scene, isn't it? You're not there in the bridge, looking at the bridge, but you have a mini scene of what that is the object itself. So I can envisage that, yeah, you can develop the same methodology whether you are working with a mini scene of something which is an actual site, or maybe like a museum that has just been kind of model somehow in paper, and then you can add, it's a bit like the idea we had with the house, having an empty house and allowing the user to populate it with objects and play around with what the content is and how can the user interact with the different three-dimensional or multimedia content that is on the book.
Okay, Salvatore Moro says, okay. I have another question. So did you experience issues when digitizing the pop-up book? Because besides being foldable, I guess that the cardboard, the paper is not rigid enough. So it's kind of non-rigid model to digitize, or?
I think the challenges are really with the intricacies of the paper model, right? Because like if you have a solid model, I don't think that the model itself is very robust. It doesn't move. So not like if it was made of cloth that is moving, but because of how intricate and how delicate these flaps are, for sure, there was a lot of noise into the 3D model. Now, our 3D model was not necessarily to be displaying the experience. You want to use the 3D model more as a means to be able to align, or maybe to have some internal knowledge of the three-dimensionality of the scene. But I can envisage scenarios in which you might want to combine the 3D model of the actual physical thing. And in this case, indeed, the quality of the geometry and the quality of the texturing would be really important to give a realistic experience.
Mm-hmm. Thanks. We still have time for one more question, maybe from the audience. Okay, so a last question for me. So are you planning to use or create tools for creating some storytelling on this context of the?
So we got in because originally we were planned to work with the Brighton Museum and the paper engineering company, right? So indeed we had go back to them, and they saw the prototype. So I think there is a lot of potential once things go back a bit to normality, because we need to have access to objects. So there is a lot of interest. I mentioned before about the expense of the production, and companies, of publishing companies that are really interested to see whether there is a market for this type of books. So I think that the paper engineering company really saw potential in exploring ways to augment content, but in a way that is not prescriptive. So a user can buy a book and view and keep building a story. It's not that this content becomes expensive, but the platform maybe to build the content is something that can be developed alongside the physical production of a book. So I think there is a lot of potential for further work in the area, not only on the pop-up book, but in this kind of idea of combining the physicality of an everyday object with ways to enhance it with heritage content.
Mm-hmm.
Yeah.
Okay, thanks a lot. So it seems there are no more questions. Thanks again, and
Thank you, Carlos.
let's move to the next paper. Second paper is about sunlight simulation in virtual reality. And the paper will be presented by Renato Saleri from École Nationale Supérieure d'Architecture de Lyon. So Renato, the floor is yours.
Hello, everybody. Do you hear me? You see
Yes.
me? I will share my screen. So might be this one. So is it?
Yeah, we can see your slides. Yeah.
We can see my screen. So So, bonjour, everyone. My name is Renato Saleri. I'm very happy to participate to this conference. I would like also to thank all the organizers of this event because it's a very important event and very interesting. And it's I didn't meant to do it, but the first picture you can just spot here is like a response to the previous very brilliant presentation. So dealing with augmented reality, and so I didn't know this very presentation would have been made just before, but it's an interesting connection because we have here the same experiment. So we can somehow imagine that all those sorts of interest in technology and displaying information is quite shared by all the community, and I think it's very nice. So besides I am Renato Saleri. I'm an architect and a researcher within the MAP laboratory, which is this French is under the authority of the National Center of Centre National de la Recherche Scientifique and the Ministry of the French Ministry of Culture. So, so starting this, I'll just move this window. So we're mainly interested in some digital-based technologies, methods and tools between information technology and engineering sciences that might be applied to human sciences and in particular to architecture and heritage studies. So this laboratory gathers few teams from CNRS and from National High School of Architecture in Lyon, Nancy, Marseille, and Paris-La Villette. And this very presentation is from the Lyon research laboratory, which is called MAP ARIA. We have to say that at the moment, this interest in cultural heritage and digital technologies put us to be involved in the scientific worksite of the Notre Dame reconstructions, and on which we can apply also tools and methods that are able, as Donald Schoen say, to capture, store, manipulate, organize, and reflect on objects of research. So this is, to my sense, a real cornerstone of this kind of research and investigation, digital investigation. So the research I'm going to present here is somehow a 6-year-long path in collaboration with another person, another researcher, who is Daniel Tardy, and has become also a very good friend of mine by the time, because we spent a lot of time together. And well, he's a researcher, but he's also a director and a filmmaker. So he's kind of used to interact with, with light, temporality, iconography, religious iconography. So this was a very interesting piece of research and working together on this research. So the idea concerning this task is all about the periodic enlightenment of the decorated capitals throughout the year in this quite little church. It's called in the city. Well, it's not a city; it's a town of Saint-Nectaire in France. And this illumination of sculpted figures seems somehow to bookmark some major festivities of Christian liturgy or of the religious calendar, which seems to be very particular, very special. So this light phenomena and light characters, symbols, figures that might appear in those very nice capitals with regularity and precision. But we must consider in this research that we have obviously used the Julian calendar, which was in use since 46 before Christ until 1582 in the Western culture. There is a problem that prevents some spectacular headlights that could happen if the surrounding hills in this small village were not present. So as we might see on this picture, you see this very nice little church, but is surrounded with those huge hills that are just around its position, its location, and that prevent the sun to illuminate some of the capitals in some particular periods of the year, which is an issue somehow, it's a problem. So this does not mean that the hills suddenly appeared or popped up in recent history, évidemment. But perhaps we might consider that all, in the opinion of Daniel, who considered all these facts, that this church was built as a copy of another church who was maybe built somewhere else. But today there is no trace that we have never found another similar, strictly similar church somewhere else. Or a more tenuous hypothesis, which is still under investigation today, is that the initial ubication of this church was maybe somewhere else. This is also a very interesting question that we might not respond now, but it's something that is definitely pending. So the underlying scientific investigation was thrilling enough to us to, first of all, simulate the light phenomena throughout the year through the development of a specific unity that all of you might know, application, and verify the effects on inner decoration, especially on the capitals. And secondly, to provide some new architectural hypotheses concerning possible former states of this building. That's why we call, so like a joke a bit, this research is a kind of solar virtual time machine. So the sun has obviously been a huge source of inspiration through history. So we have so many examples. Some of them are still visible today, like Stonehenge and many, many others. Some are quite obvious and even known since a long time, and some other are subject to speculation still today and need some further investigations to validate or invalidate scientific hypotheses. And we must say that computers and digital simulation are obviously very helpful. And since the last few decades, we're able to recreate reliable anthropogenic sun machines, we can call them, made to reproduce or verify some ancient religious or societal practice that might have disappeared. So to make this research, we identified three main goals that were very important to achieve precisely. First of all was to ensure the geometrical accuracy of the building and all of its parts. For instance, the position and the thickness of the masonry and the positioning of the bays and the windows, obviously, to let the sun through. Second was to ensure the accuracy of the sunlight model and at all the dates relevant to the scientific hypothesis that Mr. Tardy put forward. This was very important. And calculate, third of all, calculate with an extreme accuracy the orientation of the building itself, because in case of solar illumination, you might guess that this is a very crucial point. So the geometric accuracy of the building was provided by gathering around the 3D resulting model a set of very disparate data coming from, yes, as you can see here, a set of ancient documents. Here is a survey from Louis-Clémentin Bruyère dating back to 1868. And all of these documents will partly guide the architectural hypothesis of the former state of the building. Besides, we had a very complete terrestrial laser grammetry campaign. So both external, obviously, and internal, as you can see here, to try to detect all the possible details that could interact with the solar model. This was very important. And also terrestrial and aerial photogrammetry campaign with drones. Today, everyone is using drones around the scientific community. So we all know the benefit we can get from these flying machines. And And finally, also the inner capitals on which we must recreate all the possible details that could make possible to recognize and to identify particular symbols or figure of the Christianity, which was done by doing this very detailed survey of the inner capitals. And this is essential, of course, for the accuracy and the predictability of the final 3D model that we will put together. So here is also a step of the ongoing 3D modeling of the core part of this church. So the modeling was made with Maya, which is a computer software that we might use for this kind of reconstruction, for these 3D reconstructions. So we can say also something about the accuracy of the illumination model that we put to test in this very research. So we know that many solar models exist today and are also available on online. Some detailed spreadsheets or standalone application, or maybe plugins for commercial 3D application. There are some of them that exist for Maya, 3ds, and so on. But for the accuracy needed for this reconstruction, we had to count on a more appropriate database set. So what we did by using this the accuracy of the illumination model, which was provided by this Jet Propulsion Laboratory site, who exploits some NASA digital database to predict all the ephemeris of the objects that are populating the solar system. So this serves also as a reference for the Institut de Mécanique Céleste et de Calcul des Éphémérides in Paris, with which we had many valuable advice when even interacting with them throughout this research. So the granted validity of this model starts from 9,998 before Christ to December 31, 9,999. So this makes quite almost 20,000 years of granted validity for this very model. And for this simulation, we started on a time step of 1 minute, because we noticed that a time step of 5 or even more, 10 minutes was not enough to discriminate some very transient events that could occur in the church when the sun crosses the sky. So this makes quite a huge amount of data, because you have 525, well, nearly 500,000 of entries for a bisextile year. And this makes quite a lot of information. So now, dealing with the sunlight, as we said just before, it's very important to orient very precisely this church to make it as predictable as possible. And so we used here, well, I'm not a specialist in this part, this is not my specialty, but we used here a specific workflow based on terrain measurement with specific tooling software. So just to extract, which was important here on this design, to extract all the precise outline of the external walls of the church, and were applied obviously to the 3D model that we put together. So you see here within again a Unity interface. Now, the digital simulation was put to test, obviously, to know if all this previous hard work would have been efficient in terms of reliability and accuracy of the digital model. So we have here just a brief movie. I don't know, I have quite a poor data link, so it might maybe lag a bit. I don't know if you can see it in detail, but we have here a small journey through the church of Saint-Nectaire, and as you might see, the sun shade, the shade of the sun is animated, obviously. And through this little interface on the lower part, you could interact with the elements by stepping forward or backwards by a minute, an hour, a day, a week. And so just changing all the solar inputs in the 3D models, just to verify if what are the conjunctions between the solar light and the 3D elements that are inside of this church. So we can now start to compare some effective alignments with observable on place in situ this phenomena. So we could now test the reliability of the simulation with the aid of a huge photo data set provided by Daniel Tardy, who was made in 2012, which was a year where Daniel had the time to spend so many photographic campaigns around the church, so and to document precisely all these very peculiar alignments, and to check the correctness of the alignments provided by the digital model. So here just, it's not only a digital tool. You can see here, we see very few, but it's a huge Excel graphic that Daniel put together by comparing and counting almost every possible occurrence between the solar illumination produced by the 3D models and the details, the 3D details present in the church. So this is a very huge piece of work because I'm sure he spent a very long time in it. And this document was not only exploited to evaluate potentially the amount of capitals that were lit up if the hills were removed, but also to identify more precisely the alignment necessary to place or rediscover rediscover some ancient openings that would have been present decades or centuries ago. And this was quite interesting in this research. So this is the final count of the unlighted capitals in some specific circumstances. The first bar you can see here is the present state of the church, where we can see that on the 80 faces that exist within the church, at the moment, only 53 of them light up with the sun at a moment or another in the year, and 27 are never lit. If you remove, so what we did with this digital model, if you remove the hills virtually, we still have 13 faces that are not lit together at a moment or another. And if we just rely on this previous design of Bruyère that we saw in the beginning, that was just representing the building at his state before 1868, we can just illuminate two more capitals, as you see here in the third bar. This is quite interesting because we see that throughout the time this church was modified, reconstructed, demolished, and all through we can somehow rely on the sun illumination to state maybe what are the architectural elements that appear or might disappear in his history. So what's coming next? As you can see, a very old here gravure that seems to make appear some very significant detail maybe in this part. I don't know if you see my cursor, but there might be another hidden window in this part, which is interesting because we never really realized that also there could be something in this place. So this is something we will have to check in the next the next days, next weeks. So this model appears to be something that could ease the identification of enlightened faces throughout the year. And first of all, trying to do this huge job provided by Daniel, maybe by automating this to know whether each of the 80 faces is illuminated or not. So almost 500,000 times a year. And we calculate that with all these 80 capitals, that this makes more than 40 million possibilities of enlightenment or not. So this could be obviously something provided by machine computing and not by a human interaction. And we could also apply this method to some reasonably nearby churches that will maybe display the same light effects all during the year. This could be very interesting. And maybe extend also like the investigation to some new historical documents that we might find in the future. So obviously now the time is running, but so we had a few tests with virtual reality here with the HTC headset, with the SteamVR asset within Unity also. This was quite interesting to test and to put to test in this research, but maybe more with this collaboration that we initiated with the planetarium of Vaux-en-Velin. It's still going on, and we had a meeting last Thursday, and we will have another one next Thursday. So we're planning a kind of joint research in this particular aspect. So this is a spherical rendering within an Arnold rendering pipeline. So this is a pre-computed sequence, but we are putting to test with the planetarium a more consolidated pipeline to import and display on the dome real-time remote controlled sequences, Unity-based, with point clouds and meshed environments. It's funny to just to say to conclude that the pipeline, the technical pipeline that we used to display those point clouds on the dome of the planetarium were relying on some technical programs that are normally used to display stars, galaxies, and it was quite interesting to reroute these possibilities provided by the planetarium in this test. So this was it. Thank you again for listening, and if there are some questions.
Thanks a lot, Renato. So let's see if there is some question from the audience. So very impressive work. So one question. So from the pictures you show, it seems that the light in Saint-Nectaire enters through stained windows. So I wonder if you plan to simulate kind of the effect of these color glasses into the interior of the church?
Yeah, this is a very interesting and pertinent remark, because obviously the model we provided had no stained glass, because first of all, we don't know what the stained glass at that period was 1067, the built year of the church, were destructed, rebuilt, and today's stained glass are from the end of the 19th century, so that would not provide a good example to test, I think. But this might be a very good, a very good input for next testing on this church and other church, because obviously the light would be certainly diffused with this stained glass and maybe enlarge the area that is lit by the sun. So maybe it could also we will have to put to test some new set of results doing this. And we have this in mind, but it's not in project yet. It's a very good question, very interesting question, yes.
So we have time for one last question. So Gabriel Guidi says, thanks, Renato, for the great presentation. I wonder if you have considered the tool Stellarium for this type of application. Stellarium.
Stellarium, yes, we have this application. There are many applications existing, but there were maybe something crucial also, the ease of putting available data within the Unity workflow. So here we can start with a simple ASCII data set that you can choose exactly what type of data you need. So in this case, we need only the hour, the minute, and the elevation and the azimuth. Those are the four only elements that we need. And this was very simple to format, to put in form, and to make it work within this Unity render software. We consider many other possibilities, also very simple but efficient. Solar heliodome was existing for Maya that we could have used. But so the choice was on this NASA dataset, also because the Institut de Mécanique Céleste says we are not maybe very specialists in the reliability of this support. And Pascal Descamps in the Institut de Mécanique Céleste was confident with the reliability of this data set that we use for this experimentation. But maybe there could be something even better. This is possible, yes.
So thanks again, Renato, for this very nice talk. And we should move to the third and last paper in this session. The paper is about compression of cultural heritage image data. That's important. You have pictures from many views. The paper will be presented by Max von Willow from the Technical University of Darmstadt. So please, Max, the floor is yours.
Thank you very much for this kind introduction. This talk will be about segmentation-based near-lossless compression of cultural heritage image data. So basically, it deals with the problem of efficient storage of data sets, of artifacts some of you basically create for exhibition at museums or for further analysis and so on. My name is Max von Bülow. I'm from Technical University of Darmstadt. And this was a joint work with the Fraunhofer Institute of Computer Graphics Research. Cultural heritage artifacts are usually digitized by image-based photogrammetry approaches, which usually require images with high image resolutions, and hundreds of them are required in order to create accurate reconstructions. This leads to immense storage consumptions, which makes it hard to transfer this cultural heritage across many generations, making archiving more difficult. But there are compression techniques that work by removing irrelevant or redundant parts away from these image data sets and make this transfer and archiving more efficient. In order to capture these data sets, we use the cult arm 3DP, which is basically a photometric robotic capturing arm, which just moves around the object completely autonomously and creates images from different viewports and view angles. If you capture images with this cult arm 3DP, we directly recognized that our static background in the data set produces this very homogeneous regions in the images, as you can see in both examples here. For example, on the left-hand side, we have this grayish background, and on the right-hand side, we have the complete darkness in the background. But still, there is some noise in the background. Not noise like you directly observe it with your human perception, but still there and causes high entropy in the image, which makes it very hard to compress this losslessly, as I already mentioned at last year's GCH. So our main assumption of our work was that this noisy homogeneous background regions don't contribute anything directly to this photochrometric 3D reconstructions. So our goal was here to detect these homogeneous regions and replace them by an approximation that is more cheap to encode than a lossless representation of the whole image. State-of-the-art image compression algorithms suffer from several disadvantages. For example, we have the JPEG algorithm, which is not able to compress the images losslessly. So you don't have any control which parts get affected by lossy compression techniques and which part don't get touched by anything. So just the whole image is compressed with lossy compression techniques. On the other hand, we have the PNG algorithm, which is of course lossless, but at the other side it has an inferior runtime performance, and the compression rate, of course, because it's lossless, is also worse than the JPEG algorithm, for example. To be complete, I also listed the uncompressed approach, and uncompressed representation, which is of course lossless. It's of course the best, it has of course the best running time because you mainly have to do nothing on the algorithmic side. And yeah, what's also quite clear is that the compression rate is the best possible because yeah, nothing is compressed basically. So, and this leads to the requirement for our algorithm that we want to create better compression rates than the standard image-based compression algorithms with our newly designed approach. Coming to our algorithm, we have a data set that consists of a set of input images, and for each of these input images, we independently create a superpixelization first. And therefore, we use the SLIC algorithm, which subdivides the image into equally sized regions that are sensitive to the texture. As you can see on the bottom here in this example, the artifact itself is formed by an independent set of superpixels because, as I said, the superpixel algorithm is sensitive to the texture of the artifact itself. The SLIC algorithm has the advantage that it only is just the number of superpixels it should get generate. At the same time, we also compute a figure ground segmentation with this segmentation application, which automatically annotates the foreground pixels from the background pixels, and therefore it only needs some handmade initial scribbles on one single image of the data set. Like you can see on the right-hand side here, the background part is marked with a red color, and the foreground part, the artifact, is marked with a greenish color. And then this application automatically extracts the image statistics from that and uses the grab-cut algorithm to apply this statistics to all other images in the data set, producing this mask you can see on the bottom right of our example. When we have this mask, we combine it with the superpixel result, which now excludes the artifact itself, making sure that this artifact isn't touched by any lossy compression technique. So now we made sure that we don't lose any information on the most important part of the image, the artifact. But we still observe that the styrofoam, which you can see here between the background and the foreground part, may still contribute something to the overall reconstruction. For example, if you use structure for motion, pose estimation techniques, there are very much features, for example, here in the styrofoam, and it has a very big depth of field. So this would definitely make the reconstruction result here more stable. And yeah, therefore we wanted to retain also this this not homogeneous parts which are not the artifact itself. Therefore, we decided to fit a plane into each of the previously generated superpixels, and that was the reason why we actually created them. And therefore, we used the X and the Y axis of the image itself, and then introduced the third axis, the Z axis, which represents the normalized color depth of each superpixel. And then you can see on the left-hand side a superpixel which originates from the artifact part of the image, which is very, it looks like very extreme noisy here. This is because it contains texture, and this superpixel definitely should not be affected by and not be approximated by a plane. So this image should be compressed losslessly. On the other hand, we have on the right-hand side a superpixel from the background, which looks really homogeneous, and this is, in our opinion, safe to approximate using just a plane. So we are applying thresholds on the error between the plane and the actual data, and then we receive this final mask, which annotates the superpixel that remain for lossy compression, and all other parts should be compressed with lossless techniques. So we would retain the object itself and also the styrofoam here. Now we only need to store both types of the image, and therefore we store each plane equation, which basically consists of 3 floating point values, and also the mean error of each approximated superpixel. We need this mean error in order to be able to reconstruct also the noise during the reconstruction. Otherwise, we would get sharp edges in between of superpixels, and we don't want to use any in-painting algorithms here because we don't have any control why the slick algorithm creates an actual edge in the image. And there are 2 cases. For example, when there's actually an edge in the image, of course, because of the texture, or there were just not any pixels available for the superpixels, so we can't create infinite sized superpixels with the slick algorithm, of course. So there are some edges which are actually not an edge in the image. All other parts of the image are compressed using a standard image compression algorithm that is lossless. We use the PNG algorithm here as well because it's very well known. It's available on almost all systems, and it is also capable of encoding 16-bit images, and therefore it is perfect for encoding camera raw images, which are usually 14 or also 16-bit. Additionally, we also need to store a mask that makes it possible to distinguish between the lossy and the lossless part. At the same time, this mask also stores the absolute superpixel ID in order to evaluate the correct plane at the correct position in the image. Coming to our results, we have these 3 non-antique testing data sets, which are made in our lab, just to have some data to play around with. And we are very, very lucky to have also access to this Java Gold data set, which shows a meditating royal ascetic that was captured at the Reichsengelhorn Museum in Mannheim in August 2019. And this artifact itself was found at the island Java in Indonesia. Coming to our compression rates of all these 4 data sets, we receive compression rates of 1 to 2 and 1 to 4 compared to a plain PNG implementation. So a PNG implementation that assumes that the whole image needs to be encoded losslessly, So just without further assumptions. And the PNG algorithm itself has a compression rate of 1 to 1.4 compared to an uncompressed representation on cultural heritage image data sets, which I also already presented last year. In order to evaluate this, we choose a number of superpixels of 2048 here. And we did this because we tried out a different variety of different superpixel numbers. What you can see here is the compression rate on the y-axis and the number of superpixels on the x-axis. And there is some drop at the at 2 to the power of 11 when you look at the terracotta hat and the base data set. But at the same time, the 2 to the power of 11 is a good compromise for the Royal Ascetic data set and also for the Wooden Dragon data set. Yes. What you also can see directly here is that the Royal Ascetic data set, which was actually captured with the same camera like the Wooden Dragon data set, has a very better compression rate. This is just because the coverage of the Royal Ascetic data set compared to the image itself is very small. So we had a very close by capturing of the Wooden Dragon. It's just a bigger object, and so we have less background parts we can compress with our lossy technique. On the other side, you can see this drop I already mentioned, and this is not the same for both cameras. And this is mainly because we have different image resolutions. So for the head and the base data set, we have almost 4 times bigger images, leading to bigger superpixels, of course, because we have the same number of superpixels for both cameras. And yeah, if you have bigger superpixels, you wash out some noise artifacts in the superpixels, and therefore, if you get smaller and smaller, your threshold may not apply anymore, and at some point there's just a drop in compression rate. So this describes why these drops are camera dependent. We also evaluated the reconstruction quality when we compress the images using our approach. And therefore, we used the Middlebury benchmark dataset from 2014 and a naive stereo implementation, which locally optimizes the disparity values using the normalized cross-correlation error. This Middlebury dataset also provides ground truth data, so it makes it possible to compute this errors between the estimated disparity values and the original disparity values. And we first evaluated this for the original images, which were provided by the Middlebury dataset, and then we compressed these images and decompressed them again. And afterwards, we just divided both absolute average errors in order to receive this relative error you can see on the right-hand side. And this states that our disparity error is less than 1% for all our data sets, and for the most also smaller than 0.5. We excluded all data sets from the Middlebury data set here, which have a background coverage of less than %, because basically the Middlebury benchmark was made in order to create accurate reconstructions, and therefore you need much foreground structured parts, and they are less interesting for our compression approach, which requires much background parts. We also evaluated the runtime performance, and you see that the Wooden Dragon and the Royal Ascetic dataset is almost equal for our approach and the PNG algorithm. On the other side, you have the terracotta head and base dataset, where our approach is half times slower than the PNG algorithm. And this is mainly because we have two bottlenecks in our code. On the one side, we have of course, the PNG algorithm, which has to be performed in our approach, which takes much time. And we also have this SVD computation for the plane approximation steps, which grows exponentially in superpixel size. And as I already mentioned, for the compression rates, the superpixels are about 4 times greater than on both other data sets. So this describes how why we are slower on bigger data sets, and yeah, on other data sets we are almost equally slow or fast. And mainly this whole timing thing depends linearly on the data set size, of course, on the image resolution, and on the object size itself. Now again, our state-of-the-art slide, now including our approach. We presented a near loss.
Max, it seems we lost your audio. Okay, so it seems that we lost Max connection for a while. Let's see if the internet connection of Max is reestablished. Okay, so we are having some technical problems at the end of Max's presentation. So please, in case you have questions, write them in the panel, and let's hope Max will be able to join us for finishing his presentation. Hello again, Max. So we lost you, but
I'm very sorry for that.
So don't worry.
I think the Wi-Fi just kicked me out for some reason, and I had to reconnect. I'm very sorry for that. I still where did the connection drop? Can you please tell me? Yeah, the contribution slide, I think.
Yeah.
Okay, thank you very much. Okay, summarizing our contributions, we presented a compression algorithm that shows up much better compression rates compared to the standard image compression approaches. It is very to implement, so you only need to implement the segmentation thing and the plane fitting, and some image compression algorithm is required, some lossless image compression algorithm, and it is very transparent in design. So you can at all time visualize the lossless and the lossy parts, which gains you control about the compression itself, and makes it easy to supervise the whole thing. So that was my talk. Thank you very much for your attention. I also want to mention that we made the source code for this whole project available. If you want to have a look inside this, you can do so. Thank you very much.
Thanks a lot, Max, for your presentation. So we have 1 minute for questions. So your method does not require the images to be registered, but in case they are aligned, do you plan to somehow use this extra information for the encoding? For example, the masks are almost can be retrieved from if all the images are aligned, I guess.
So the segmentation mask actually was incorporated between all images in a data set, of course, because you apply the scribbles on basically the whole data set. But the compression itself, at least for lossy compression, can't make any use of the interview redundancies, basically, which I already talked about last year. We tried to incorporate pixels and wanted to transfer them into the next view, and then wanted to calculate the distances, which worked very bad because we have this noise in the background, which doubles by the subtraction you apply when you transfer the images, the pixels into the next, into the neighboring view. So this is, yeah, this is unfortunately not so easy possible.
Okay. So thanks a lot. I think that everybody working with photogrammetry and large image collections will find your method really useful. So thanks again. And let's move to the poster session.
So hello. We are about to start the poster session. Just checking everybody's here. Yeah. Okay, so welcome to the poster session. We have 3 posters in this session. I'm not so sure if Javier, could you just confirm that everything is okay? Because
yes, all of them are there.
Okay.
And the posters are on the website also.
Okay. And the image looks okay, right? Because I can only see your image. Sorry. Yes. Yeah, okay. That's it. So welcome to the poster session. We have 3 posters for this session. So we're going to start with Javier Puello, who has the first poster, Digital Layer Models and Medieval Mural Painting. Javier, do you want to share your screen? Javier, could you put your video and share your screen, please? And Javier, we cannot see you.
No?
Yes, now we can see you.
But not the main screen. We can see the presenter screen, not the the full
maybe
screen. Share the full screen.
May you hear me?
Yes.
Yeah, we can hear
hear
you.
you.
Okay, I will arrange this. Come on. Better now?
Yes, that's better. That's right. That's okay.
Thank you. So, do I start?
Yeah, please start. Yeah.
Thank you. Thank you, Karina, for your introduction. Good afternoon, ladies and gentlemen. I'm going to present a poster that do not show results of research, but presents a project that just started last September, so 2 months ago, more or less. As a consequence, we have more questions than answers. Anyhow, you may ask, and we will try to answer. Well, the project aims to build digital models of architecture and mural paintings of Middle Ages elements along time, at different times. So what we are actually looking for is the biography of our monuments with all the details we are able to put in these models. And it's oriented to researchers, restorers, and curators. As a consequence, given that we will have better models, we will improve the visitor's experience, so the general public experience. It's a project in the context of the program Cultural Heritage Challenge for Europe of the European Commission. And this is a consortium. The consortium is led by Universitat de Barcelona with Professor Milagros Guardia is a project leader, and the other partners are Rice Research Center, Roma 3, and Universidad de la Tuscia. Hope the pronunciation was acceptable. In addition to these 4 institutions, the consortium, there is also the Cyprus University of Technology and 4 Catalan universities under the umbrella, these 4 of Universitat de Barcelona. Our project has 4 main specific objectives. 2 of them have technical challenges. The other 2 are more oriented to the interpretation of the cultural heritage. The first concerns architecture, where we want to really understand the buildings and their structural anomalies. Here, complexity has not a relation with size, because often, like in this image, our monument is small, quite small, but they are built in complex, let's say, spatial emplacements, like this one, which is in a slope of a mountain. The second is painting, where the problems to solve will be chromatic problems derived from the fact that our frescoes has suffered different restoration criteria and has suffered different aging processes. The third one is lighting. Here we do not think to do research on lighting as a rendering tool, like the paper presented in the previous session. We will use already existing techniques. What we look for is to give analysis tools to the art historians' colleagues. And the fourth one concerns to church users. The church has 2 kinds of users, the clergy and the laity, and they have different points of view, like both physical, so they're placed in different points of the church, and conceptual. They have different interests. We have 3 cases we choose. Santa Maria Antigua represents more than 10 layers overlapping. San Quirze de Pedret, in addition to the fact that there is 2 overlapping layers, a principal characteristic is that a part of the frescoes of this church have been transferred to 2 different museums, and this has been done in different moments using different procedures. So the aging resulting of this are different. And
this is 30 seconds left.
Okay, thank you. And Angios Monastery, where the main characteristic is the extreme nature of the site, where with irregular surfaces, because this monument is excavated in a rock from a cave. The project has 4 blocks, always on the supervision of art history experts, and is organized. This is implemented in a number of work packages, gathering the information already existing, obtaining the missing information by digitalization, and restoring these items, and integrating them in a platform for which we have choose Aioli. And finally, they have the block of visualization for the different final users of our platform. Of course, there are other work packages of management, diffusion, and evaluation, etc., etc. And that's it. Thank you very much and for your attention. And I'm sorry for sending me a little bit more than 5 minutes.
Thank you, Javier. Can we pass now to Valeria Garro? Valeria, if you want to share your screen, please.
Sure. Can you hear me?
Could you? Yes. Yeah, we can hear you. If you want to share your screen.
Yes.
So Valeria, you can start straight away, please.
Yes. Okay. Thank you. I'm Valeria Garro, and I am an associate senior lecturer at the Black Indian Institute of Technology. So I'm going to present this work in collaboration with Black Indian Museum. And in this poster, we present an ongoing case study on the use of AR technology that is applied to cultural heritage. So we discuss possibilities and challenges of using AR for portraying 3D artifacts. So as we know, VR and AR provide an added value to the visitor experience, for example, interactivity, the sense of presence. And in this project, we want to explore the use of AR in the portrayal of the Mjällby crucifix. So the Mjällby crucifix is a late medieval triumphal cross, originally from the Mjällby church that is located in southern Sweden, and is currently displayed in the Black Indian Museum warehouse. So this artifact is displayed and lying in a horizontal position on a low stage, and usually it's surrounded also by other artifacts. So due to the current position and its large size, it's not possible for the visitor to have a close view of the artifact. So we developed an AR prototype application to display the 3D replica of the crucifix. And the prototype has been showcased to a group of experts from the Black Indian Museum. And in that occasion, we also conducted an online questionnaire and a group interview. So for the prototype, we had to perform the acquisition of the artifact, and we use our Artec Leo 3D scanner. We have followed, as you see from the diagram, a very classic pipeline for the digitization of the artifact. So during the scanning acquisition, the scanner performed automatically a pre-alignment of several scans. And we then clean the scans from the unwanted elements. We perform global registration, fusion, and mesh amplification. And the final mesh, it's about 400,000 faces. So the final 3D model was integrated in a marker-based AR application that is based on Android with the AR core library and SceneForm framework. So we involved a group of experts from the museum, and we investigated the possibilities and the challenges of using AR in the cultural heritage context. So first, an online questionnaire focusing on general AR application has been filled by 4 experts. Then we showcase the AR prototype to 3 of them, and then they participate to a group interview that has been divided into 2 parts. So in the first part, the experts discuss about the possibilities and challenges of the use of AR, considering the demo that has been shown to them, and also specific exhibition of the Black Indian Museum. And in part 2, they continue a discussion, but we include also a list of additional observation that has been prepared by the moderators. The aim was to include a different perspective in the discussion and also to gather insights about the potential knowledge gap between experts of different fields. So the results, we present the results in this table. Of course, I don't have time to analyze in detail all the results, but I can explain how to read the table, and I will be happy to answer your question on Discord or email later. So the check marks indicate during which part the aspect of the group interview of the questionnaire, the aspect has been discussed for the first time. In red are highlighted the aspects not mentioned by the participants, but they were part of the list that we have prepared. And in blue, there are new aspects, but mostly example introduced by the participants that were not considered in the prepared list. For example, during the group discussion, the participants suggested example of AR application that we moderator had considered before in our list. So as future work, the results from the questionnaire and the group interview provide new insights to take into account when we are going to continue the development of this AR application. And additional future work, we are planning also a showcasing the AR prototype in the original location of the artifact, the Mjällby Church, and collecting on expert visitor expectation and feedback, and run also a usability study of the AR application. Thank you very much.
Thank you very much, Valeria. Can we move to the next and last of our posters, which is Anil Ozdemir? Anil, do you want to show your video on your screen? So Valeria, you stop sharing yours?
Sorry,
Yeah, that's
yes,
right.
I done it.
That's
Sorry.
okay, that's perfect. And Anil, are you you able to share your screen, please? As well as put your video and your microphone on. Anil? Okay, I think we have lost Anil. I think he was here, but he has left. So we're just waiting for the last speaker to join us. We have the last poster, an NLP Enhanced Visual Analytics Tool for Archives Metadata, which I thought was quite interesting, but we're just waiting for Anil to show. His screen, I think he has dropped from the connection. Let me see if I can find. I think, Javier, do you want to wait for Anil to see if he reconnects? Or do we?
I promoted him as a panelist, but then disappeared. It seems
Yeah.
as he has bad connection, or probably the Zoom version he has does not allow.
Okay. Maybe.
Yes,
oh,
now
Anil
it's
is here.
Okay.
Okay.
Okay,
Anil, do you want? Perfect. Do you want to share your screen, Anil? Perfect. Okay, so 5 minutes. You can go, please.
Okay, hello everyone. I'm going to, do you hear my voice?
Yes.
Okay, today I'm going to present our study named as the National Language Processing Enhanced Visual Analytics Tool for Archives Metadata. Our motivation was, in recent years, the cultural heritage institutions have started to digitize their collections to improve accessibility, preservation, and visibility. And these collections are spread over more than one area, including art, history, mathematics, and physics. And this will allow large amounts of data to come out digitally. And such a digital reconstruction of these collections also creates a need for approaches that allow researchers to understand latent meanings, discover relationships, and to extract necessary information from the collections. And to help with this issue, we introduce a visual exploratory tool that help users in terms of uncover the hidden stories, highlight the key attributes, entities, locations from the documents. And with this kind of design, we prepare an easy environment that let researchers and archivists to form and test their hypotheses and to observe their findings. In terms of dataset, we have collaborated with the archive professionals from a cultural institution, SALT team in Turkey, and decided to use Wax of Crete, which is newly digitized collections that include Turkish and Greek inhabitants of the Crete island. And documents generally cover the years between 1825 and 1825 and 1928, and gives us the insights about the multi-layered social structure on the island, especially from a cultural and economic perspective. Also, these metadata contains 10,000 documents. Our system actually consists of two parts. The first one is extract attributes through metadata in the visual, and the visual tool that we designed for that. And here you can see the steps we followed while the extracting information from the metadata. Basically, for extracting attributes, we first located the element of sentences those words corresponded to, such as nouns or title or adjectives, noun phrases. And then we determined what type of entity they refer to. It can be key individual, time, location, or keywords. And we got help from the regular expressions and the morphological analyzer and some of public Turkish knowledge base APIs. In here, location means not an exact location because we already have that in the metadata, but it's actually refers to the local villages and settlements that never heard before. And the concept of time is the time progression, like such as morning, evening, the next day. And here you can see the steps we have followed while determining the similarity between documents. In short, we create a corpus based on the summaries of the documents, and we trained various word embedding models on the created to create a fixed size mathematical vector for each document. Then we can measure the similarity between them by taking the cosine similarity. And as a final, we use the people and keywords belonging to documents to came out a information extraction model to draw a network between the documents. And if there is a common person or shared keyword among the documents, we construct a weighted edge between these documents. And the weight here corresponded to the total number of common attributes. And in the visualization part, we actually kept all information we extract on a database, and we try to establish an interface that can pull the desired information by sending a query to the database continuously, and used JavaScript for this and used Core2JS library, and we kept our data on Core2JS on server. And our proposed interface has some main components, and the first component is the interactive map. And by
Nearly
this
5 minutes now. 5
Okay.
minutes, so could you please wrap up?
Okay. And one is the interactive map, and user can also view documents outside and inside of island of grid and around the world. And there's some information box that we present our extracted informations from the documents. And there is some document browser, and user can display the output results in the document browser. And there is search menu. You can search the person or key individual and see the extracted network among the outputs. And also you can filter the outputs according to some attributes. That's it actually. This is our proposed tool. And by this tool, people get chance to witness a person living in 19th life. But application only was tested and designed on the wax of Crete archive, but it needs to be tested on another data from another domains. Okay, thank you for this.
Thank you. Thank you, Neil. So that's all for the 3 posters. So thank you very much for watching. The next session starts at 3 o'clock Central European Time, and see you later.
See you later. You have now 20 minutes for rest a while, and then we meet in 20 minutes. Okay. Good morning, everyone. Or good afternoon, or good evening, depending on the time zone where you are living. It's 3 o'clock in Central Europe time, so it's time for starting the panel, graphics and IT and technologies to help cultural tourism in post-COVID era. We are very conscious that now it's a very hard time, but the future doesn't look much better. And it's our task as scientists, as people involved in developing new opportunities to help other economic sectors to make a better world and to make the less difficult the restart of our economic lives. So for that purpose, the organization of the conference has decided to set this panel that shows a very wide spectrum of the stakeholders involved in the cultural tourism aspect. We have Marco Calieri from the ISTCNR, which is a researcher, top researchers in the field of computer graphics applied to cultural heritage and to solve real problems, as he defines himself. José Luis Córdoba is the manager of Andalucía Lab, which is a hub of innovation in southern Spain, in Andalucía, where all the startups, new products and services offered to the tourism sector are centralized and also promoted all around the world. Mauricio Forte is one of the pioneers in applying computer graphics in the cultural heritage since some years, not many because he is still young, but he's one of the reference for all the people that has researched in this area. Giorgio Genta is the president of ETT Solution, which is a company with very impressive and a very wide background in developing technological solutions for the tourism, mainly in Italy. And Gemma Ila is the curator, the specialist in Romanesque art in the Museu Nacional d'Art Catalunya. And she is representing somehow the museum part of this, because we, as researchers, we know that we are not alone in the world, that we need users, people that makes requirements, we need people that commercialize it in the tourism, companies that develop. So that's why this round table, this panel, has such 5 different point of view. So we have just 1 hour, and we will start with the main question, and to start the debate. So how can graphics and new technologies help cultural heritage tourism in a few months when everything is solved? So we will start one by one, and please, I think that Giorgio Genta has a presentation and can share and start sharing this slide and telling us the point of view of a company that is already implementing new technology solutions and how it can be implemented and improve the sector in the following years. Thank you for coming.
Thank you, Javier. And thank you to all for the invitation. I can start my presentation. Okay, like this. Okay, can you view all? And okay, thank you. I'm Giorgio Genta, the Vice President of ETT. ETT is a company based in Italy, but with international clients, and we are experienced designers. So we are an international digital creative company that combining state-of-the-art technology with innovative storytelling for museums and touristic sites. What we do exactly, we are working in several sectors like retail, events, museums, tourism, entertainment. these are these are projects that we did in the past, and exactly what we do. We do exhibition design, we do digital signage, virtual reality, augmented reality, multimedia guides, app, touch technologies, immersive projection, and also gamification and sensor for our project. Just some numbers. We have delivered about 100 museums, and in our history, we have now 20 years of histories, and 1,000, more than 1,000 installation, multimedia installation, for over 400 completed projects with a team of 150 people. And so to answer the main question, I can share with you some our project that we did in this period. And the first one, and this is a video that explains some our project. This is, for example, Penacolo Vintano in Milan, in which we use augmented reality. Also, we have the Musei Capitolini in Rome with the innovative audio guide, multimedia guide for visiting the museum. So we are expert in virtual reality and exhibition projection mapping for museums. These are some examples that we can use. The time is short, so I go on with some example. This is a very important project that we delivered just at the end of the first wave of COVID-19. We delivered in June in Italy, in Florence, and this is our project in which we start to open new museums after the first wave of COVID-19. This is a museum of Casa Dante, the home of Dante Alighieri in Florence. And the main goals that we have was the strengthening of the identity of the museums, to enhance visiting experience through storytelling, and mainly create an immersive experience, and mainly open the museums to the city and the territory. And we use in these museums a lot of technologies like holograms, like gamification, virtual reality, projection, touch monitors, lightbox, NFC tag, PIR sensor, and a lot of we have. This is an example of the hologram of the head of Dante Alighieri, for example. And we have touch monitor, card with the NFC tag, and projection. And we also reconstruct the Dante masterpiece with the immersive and emotional experience with the projection mapping. Very, very impressive, very emotional, this kind of installation. And also we use virtual reality with 360 video to explain how is now Florence in the place of Dante at the times of Dante Alighieri in the 13th century. It is a short video that explains exactly what we did in this museum.
If it has sound, we cannot listen anything. Giorgio. The sound is not available. But anyway, just 1 minute more.
Okay.
Okay.
Okay, thank you. So I leave your okay. So the current crisis is critical for the museums, as you know, and for the cultural sector. People begin to feel nostalgic to have an experience of visiting museums, and now it's possible with the new technology to have the possibility to visit many cultural sites with a single click, for example, and using digital transformation and digital technologies is possible to do this. I have also other example, but I can share it after.
Thank you, Giorgio. I think that we will have time to see more of your experience in the further discussion. José Luis Córdoba, as I told you, is the manager of Andalucía Lab, a marketplace of startups and innovation in the tourism sector in Andalucía, but from Andalucía to the whole world. And José Luis, we could ask you, as an expert in tourism, how can computer graphics and IT help your sector in the future?
Thank you. Thank you very much, Javier, for inviting me to this interesting panel. Okay, I would say that Andalucía Lab really its main goal is to help travel companies throughout the travel industry. I mean, hotels, restaurants, and museums, and other kind of activities that make up our industry. We started to operate in 27, trying to help these companies to be successful in the internet when the internet disruption started in our industry. So during these years, also some companies and travel companies, tech companies that which customers are in the travel industry, mainly hotels, approached Andalucía Lab because they need bridges or ways to market their services. For them, was very difficult to market some of their solutions. So they saw in Andalucía Lab an ally to help them, to approach to them. And in the cultural sector, mainly we have some experience because there are a lot of tech providers that are trying to work with you. And at the same time, it's for them was very difficult to really to approach to these customers and start a way of dealing with them. So well, this is what we do and why we really started to work with the cultural sector and at the same time with the tech sector. So what I am going to try to answer this question, I'm going to share my screen. Okay. Okay, do you see my screen, I suppose? So my slide, okay. So I think that we have very good news. I mean, there are a lot of opportunities to add value from these computer graphic technologies, both for the suppliers and also for the consumers. Of course, many of these add values are shared or common, but for example, if we think about the supplier, some of the technologies, as Giorgio explained before, can help us to engage customers, for example, in the first phases of the booking process, or to get a recurrence with these customers. Of course, create awareness about hidden products. There are a lot of cultural, cultural products that are hidden. For example, in Andalusia, it's incredible. We have enormous resources and many of them are not known. Of course, create storytelling, so stories around these products, and of course improve the experience of our customers, make more understandable the product and enjoyable through augmented reality, gaming, 3D print, virtual reality, 360 content, and so on. So there are a lot of opportunities to help suppliers. At the same time, for consumers, consumers are really willing to obtain a benefit from these technologies. They want to increase the understanding and the attractiveness of this product. They want to be to make more enjoyable the product, and we can help also the consumer to remember the experience. That's a very important part through this booking and experience of the traveling in the behavior of this consumer. So here we have a lot of opportunities to help from these techs. Maybe the question is that, okay, this is, we see the opportunities, the tech is available. Now is even more available than in the past. It is even possible to create self-content or to obtain self-created content. But the question is how do we use this tech to boost our revenues and our sustainability? Here I think is the question, and it's of course not very easy to answer. How to make them more social connected, because I think that many of the proposals that we make to the consumers are not thinking in the social side of the experience, and of course more profitable. So as I said before, we have tried to help some of these travel tech providers and approach them to museums, for example. But the difficulty is to find this business model that can help both. How can we obtain incomes providing these tech services at the same time that museums are going to increase their incomes? So it's not an easy answer, but at least in our experience with some experience with certain customers, we see that there are possibilities. So maybe I have more questions than answers.
Well, that's good. That's good. Maybe you may find some answers here or not. For that, we have Mauricio. Mauricio Forte, as I told you, is one of the pioneers that linked 3D world with the humanities. And I think that he could provide some hints on your last question, how to obtain social or economic profits, because not only the economic profit is necessary, also the social. And we also have here the point of view of archaeological sites, because museums are a quite controlled environment, but an archaeological site with the sunlight, with the rain, with the forest, etc., is not so easy. And he has a lot of experience on that also. So please, Mauricio, how can we, the computer graphics community, help the tourists in this new era?
Thank you. Thanks for inviting me. Good morning from North Carolina. I would start with a survey, actually, and it's a quite recent survey in the pandemic period, the impact of the COVID-19 situation museum. And I want to see here, I want to show you here, so some numbers, because there is a clear new presence of museums online. You see that new exhibit here, virtual tours, social media, featuring individual object for the online audience. But from the opposite side, see what happened here when you the survey asked, did you hire new staff? Well, over 96% said no. So well, there are no new investment, and this might be a problem when we go back to, let's say, a different planet. I don't know if it be normal or not. So my discussion today is much more focused on also my work I do with students at Duke University. So we work on some social aspect of the question we discussed today, and the definition of co-creation might help to understand that we need to extend the experience. So they don't. It doesn't matter if we're talking about archaeological sites or museums, collection, gallery, but the co-creation is actually important in order to have user co-participating into several activity. And then the actual other speakers already introduced that importance of gamification, museum, creation of a new narrative. We cannot stay on the same narrative we had before. Also the importance of online community in order to design new storytelling, to open a multivocal world to the interpretation of science, artifacts, and art as well. So in other terms, this process cannot be entirely top-down as it was before, just from curators or just from museums. That to be part of a new co-participated activity. And I believe in this context, the collaborative social and virtual environment can play an important role. And the question about 3D printing, actually, it's important as well, because I think we will see soon a 3D prints on demand, which is actually part of what we should expect from the museum and the user side. Other trends that we are tracking in research, education, and the market as well, it's VR and AR productions for enhancing the content archaeological sites, park, and so on. And this is interesting, the increasing use of smartphone and social VR headsets. So virtual reality headset is not anymore for research, but they are actually part of the social activity. So they are part of this co-participation in VR. I believe that also itinerary virtual exhibit is a part of the new phenomenon we have to see and we have to consider. This is Sarah Candida, a very beautiful exhibit traveling from Hong Kong to Asia to Europe. Our project here in northern Italy, Reggio Emilia, was actually we built a Roman, we reconstructed the Roman city on top of the modern one, including the landscape and so on. And this is important because of the cultural identity in diachronic term of the city itself. New experiment, the collaborative VR museums. We're using Mozilla Space VR, where we have a co-participation of different users in the construction of the museum, which actually doesn't exist. It's not. It's a museum around a virtual museum around an artifact. It's not an existing museum reply or replicating to the online world. And in terms of 3D printing, this is an interesting prototype we designed at Duke University. It's called TITA, Tangible Interactive Table for Archaeology. The entire table can be printed out and assembled at home. So you can print your single temple and can play in this puzzle, able to reconstruct the Roman Forum. The idea in this case is to combine haptics with virtual reality. So basically, you have your desktop space, and then you can put your print, and then you see the result on the screen. This is the prototype, the release 1.0 that we are now at the 2.0, and we continue. To conclude, another example of hybridization, and I would say combination of different media. I call this media redundancy because in the reconstruction of Basilica Ulpi in Rome, we use 3D prints, augmented reality, and holograms in the same exhibit. That's something like Giorgio that explained before. The importance of this narrative is based on the fact that the different media can stimulate different feedback. So different interaction level from the user-visitor side. So you see the same content, but you don't learn at the same way because every single installation can develop a different level of embodiment. And back to the excavation as this panel require, I want to share what we are doing in our excavation. This is Volci in near Rome and central Italy, where our archaeological project is based on the very accurate digital reconstruction of the excavation. Look, this is not a reconstruction. This is based on a different research questions. How to deliver an archaeological excavation, which is a very complex environment, to the audience. Because it's extremely difficult to understand an excavation, not a building, not a very fancy artifact, but just ruins, foundation walls, something it's already damaged across the time. And that's something I like to emphasize, because an archaeological park is extremely important, which is where, for example, it's difficult to understand, even to read panels. And I want to conclude also on something else that we are dealing with, how to see, how to evaluate design in virtual sites, in virtual or augmented reality application using non-subjective evaluation. Well, this is a new project called Virtual Reality Neuroarchaeology. We combine EEG and eye tracking system. This is my brain, if you see in real time, why I'm walking through a virtual excavation. It's something we had just started, but it seems very promising. Actually, it's based on the evaluation of the kinesthetic approach of the user. So what happened into the brain, why we walk through an archaeological site, or why we see an artifact, or why we have to understand a particularly complex environment, and so on. I can talk maybe later about this, but I think this is extremely promising in order to have to evaluate the unconscious response of the human interaction through VR and so on. So maybe it doesn't respond directly to the question of the panel, but I believe that this could be very interesting in the future perspective. So how we can deal with this and how we can create new models for expanding the experience and also making the experience more effective in virtual reality in museums and sites and so on. And I'm done. Thank you.
Thank you very much, Mauricio. Also very impressive work and very well linked to what Jose Luis and Giorgio told. But I wanted to I think that all the audience can want also to listen the other side from the museum's curator, from the who request this kind of solutions. I want just to remind the attendees that the questions and answer panel is open, so you can at any time write your question and we can formulate it to the panelists. Gemma is as I told you, is a Romanesque art curator specialist in the Museo Nacional d'Art de Catalunya, and they have some virtual reality setups. They use they have participated in several research projects. I remember the Portalada, etc. But from your point of view, that you are one of the the most damaged institutions in this era, how could computer graphics and the IT helps you? How might help you in the new era?
I think that computer graphics can help us a lot to better understand and to better enjoy heritage or art. But I think what we really need is you, the professionals, to work with. Because I've got the impression that we have a kind of knowledge that we are not able to transfer in a technological way. And that means that we need a team with different kind of professionals to share what we know and you to share what you can do with our knowledge. That's something that should be done not only with companies, graphic companies or institutions like the ones you are working in, but also in marketing and in how we can use your technology to understand better our publics and the people who are not our publics and perhaps would like to be and enjoy to be. That's something that I don't know how to work with, because everything that comes to the museum is mostly a product that is presented without the sharing the knowledge in the museum. You already have said something about we need to change the perspective. Most museums in the world don't have enough budget to present the perspective they want to. And we are now intending to change it with technology without scheduling all the things that, all the knowledge that could be shared with publics. That's something I think it's very, very important. I think museums are in a position that are weak now, in the way that, for instance, the ICOM is trying to define museums, and is almost a year that it has no a good definition for museums. So we are talking to include not only collect, research, and deliver information. We are talking about things like engagement, experience, communities, diversity in all different kinds of diversity, sustainability, transparency, democracy, participation. This is something so different that what we have done in the past, that we need to make teams to think in a long term for the community to be in the museum, to create with us, and to change our roles, although every one of us should have the knowledge to share with others.
Awesome. As you may see, Gemma has given an absolutely different point of view than what we are used to see. Sorry, I interrupted you.
No. But, I work in a collection which is mural painting that used to be in small churches in the Pyrenees. Some of them in UNESCO World Heritage Site. So there's a long to be explained about how they came here to the museum, how they were created in the 12th or 13th century, how is the place of origin at that moment. There's a lot of connections that obviously can be done through technology. But what happened when we've got the painting in the museum and we would like to enjoy the painting without all the technology all around? What has to be done? Is this something we have to make apart, or we need to project and use technology in the work of art? So I've got more questions than answers, but one thing that COVID has done, I think, in most institutions is that we realize that technology is not a department. Technology is something that has to be transversal in the whole staff in the museum, that we need to learn to have more skills than the ones we have, and we have to have teams, all multidisciplinary teams, to work to better include technology in our institutions.
Thank you, Gemma. And the last but not the least is Marco. He's here from the point of view of the researchers, the computer graphics people, community that have been pioneers in several techniques, software, and tools that are widely used all around the world. But Marco, after all this background, what can you offer to the Turing Sculpture?
Well, this emergency did something. I mean, it proved that what the research was trying to do is to put things available, make it shareable, and make it collaborative was a thing that was actually useful. We're contacted by different institutions during this period, but mostly on the teaching and working side. So not so much museum to share with the general public, but with the university that wanted to put data online and collaborate with teachers and students, or between different scholars in different parts of the world. But the thing about working with the general public is sometimes more difficult, especially because it changed the perspective from the research between scholars to the dissemination part. So problems. I heard many persons say, after this emergency end, I don't want to see a screen anymore. So everything that we want to propose should possibly be outside of a computer screen. Maybe on a smaller screen used in a museum, but people they will not reject it completely, but for a while they will love to do things outside the houses. So things that need to be done may be done in a more distributed way. The other problem I see is that when we have worked with museum many times, we found little or no infrastructure for our staff. So we made like interactive kiosk, and they had no space to put in the museum. They sometimes didn't have a power outlet in the room where they wanted the kiosk to be. No Wi-Fi, no personnel able to turn on and off and find if there was a problem. And that thing has not changed very much during this emergency. As Maurizio was saying, how many people have the museum hired to work on these sites? Not many. So that problem will remain. This is why all the museums that I saw during the emergency doing some outreach to the public, they exploited public platform, social media, so they were able to do in-house, sharing a camera going around the museum, making a live video explaining something, organizing some of these workshop event online, exploiting existing resources, which is perfectly fine because it's much easier to reach the public through a social platform or a public platform that's already used by them, and not please download this software that you never heard about, and we will do something there. So on one side is good. On the other side is the demonstration that some kind of infrastructure to do a more cohesive outreach is missing. About the other point that have been raised, on the virtual side, on the virtual reality side, I have a headset display. And as many computer scientists, I know a lot of people that is really about technology and games and whatever. But among all those guys that I know, and I know too many of them, there are not so many that have an headset display. So there's still very low penetration of this kind of technology. And I was really curious. I expected that in this emergency, on the digital store for this kind of devices, you would have seen hundreds of very small but made by museum product for showing art and museums and this kind of. But I haven't seen so many. There have been from March to now 3 or 4 on the Oculus store, among like 1,000 release of the software. So there was not really much effort on that side. I know it's been a sudden emergency and it was not planned, but I expected more people to jump on this opportunity. I've seen more stuff coming out for a smartphone, even though it were maybe just a virtual tour made with 360 images and short videos embedded in an app, in a cell phone app that was basically just a set of 3 or 4 videos, one after another. But the virtual side is still sorely missing on this account. 3D printing and fabrication, I really believe they will change also the way the museum is filled, because we are really able to prepare new exhibit completely digital and fabricate them in a much quicker and much cost-effective way as the complete manual process. That I do believe that will help a lot. So again, not many solutions, but more problems to address. But yeah, it's a starting point, isn't it?
Yes, thank you very much, Marco. Before people start doing questions to the panel, I have more questions to you, and they are open. And I have one which is probably not very politically correct, but you know that I am a bit out of the control sometimes. Are these solutions like those ones? I mean, I can do firstly the right questions, and then my reflection is for Giorgio or for Gemma or any one of you. But how many people has been attracted to a destination by this technology sets, virtual reality or augmented reality? Or the other question, are these big fireworks installations more a matter of marketing than a real attractive for the visitors? I mean, what's the difference in a museum from, if you, for example, Giorgio, in one of the museums that you have shown, did they experience more visitors after the virtual reality or augmented reality solution or not? Or from the Gemma, do you think that having this 3D installation about the frescoes are attracting people to the museum, or are at least improving the experience of the people? Do you have some measurements? Because as Jose Luis knows, what is not measured cannot be improved. So how, or from the point of view of Jose Luis, that also has a wide point of view, do you think that really these new technologies have incidents, have results, make results in the destinations?
Javier, I would ask another thing about your question is how many platforms that really dominate the market use this technology to attract visitors. So that's Booking.com or Expedia. For example, Expedia tried in the past to do something with 360 degree visions to attract customers, but how many platforms that really dominate the market are using that for attracting customers?
I would like to share with you that we have a quite different experience, because we don't have technology in the exhibition rooms, apart from this thing about Ripoll that was reused from a previous exhibition. And in fact, there's no, when you've got the technology for one to use, it's in the exhibition room, and only teenagers go there to look what happened with the computer, and that's it. because a lot of people don't have even the necessity to go watch that big thing here in the room. That's one thing. What we have is that we are in contact with a lot of archaeological sites where some of the objects came from in our museum. So there's like an attraction to copy the paintings we have in the museum to be exhibited in the original churches. And that's something that's repeatedly used for tourism to attract people to a faraway place from Barcelona. And that's not bad, but it's an experience that sometimes is not repeated, because when you've seen something, you just seen it and you don't go back for other things. So we think that it's much more important activities than copies. Although the copy is there for, like a decoration, okay? So it's the tourism who's looking for new attractions, and those are copies of our museum pieces.
And Giorgio, what's your experience of your
Yes.
hundreds of setups?
Yes, in our experience, we have measured that when we install a multimedia experience in a museum, the ticketing is rise about 20-25%. We have measured that. And for example, our one of our last installation in Georgia. Can I share the video, the screen, or there is no time? Or,
yes, you can.
We had about 80,000 people in 3 months as visitors, and normally the museums is visiting about 10,000 in 3 months. So I share the screen to explain better what is the installation, and can you view it?
Yes, we can.
This is the Imagica, an exhibition, Italian art, a journey into beauty. It's an exhibition about painting of Raffaello, Botticelli, Leonardo, and so on. This is an installation in Tbilisi, in Georgia. There are a lot of project mapping. This project is about 7 meters high and 4 large. There are some things.
No good sound, Giorgio. No, nor images. So it's hard to. I think that you cannot send a video and then speak at the same time.
Right.
But
And,
we can make an idea of the exhibition.
Okay. So we had about 80,000 visitors in this installation. So we have some data about the number of ticketing that are sold after the installation of multimedia. The challenge is to make technology hide and not the technology must be not the protagonist, but is at the service of arts and of the exhibition, obviously. And it's important the work of people that are expert in storytelling, are expert in the content design, and user experience design and graphics, creative directors, and not only programmers or not only technicians. It's the challenge is this.
And related to this question, there was one spectator, that one attendee that says that maybe the best way of measuring the impact of the technologies is not a special exhibition, but the application of them to the regular material, because one special exhibition usually gets a lot of participants, but in the day-to-day, in the regular exhibitions, is probably Mauricio, do you know, have any experience where the regular usage of new technologies impacted positively in the visitors?
Yes, I was actually yes, I didn't mind to say something like that, and I agree with Giorgio that there is a clear, I mean, we have a clear evidence statistically that ticketing increases when there are specific, I would say, catalysts. Let's say, and not just the digital, but the entire design. You know, that they integrate an integrated communication project, for example. So some numbers. So I briefly show you the Regium Lepidi project. Reggio Emilia is a small town. And we made that virtual museum inside the archaeological municipal museum. The first day of the grand opening, in 3 hours, they sold 5,000 tickets that they don't sell for all the year. Okay, it's a small museum, not a big one, not the Imperial Forum Museum or not other museum we have in mind. But that's not that's just the beginning. So I like to say that all the installation inside the archaeological museum that were used, they are still used. Well, not in this period, but because of the lockdown. But for several years, were used by educators, by schools, and by others. So basically, there was a continuous attention over them, and this is particularly important in a city where the Roman identity is hidden. If you walk around the city, you see basically the 16th, 17th century city, or you see the Via Emilia, but you don't see the Roman city. So you have to imagine that in a very difficult imaginary puzzle. So that was a kind of reinforcing the citizenship memory, refreshing them the memory and bring them to them. So returning the memory of the Roman city. Again, this is was made thanks to also the Lions Club, a lot of local donors that they helped the project. But this, I think, is a tangible example where you have artifacts, that you have archaeological finds in the museum, but people get bored because they don't understand where do they come from, what they are for. There's no narrative at all, just a short caption. And this is my last slogan against some archaeological museums. If we continue to invest in taxonomy and not in communication, it won't be any future for archaeological museum, because once you embrace the taxonomy, you give up the interpretation, including the scientific interpretation, because the meta language doesn't explain the context. The meta language doesn't explain a very curatorial description of one feature of the object, very likely even not the most important one. So this is based on, I hope, a new understanding that we need to recontextualize at the multidisciplinary level this kind of communication, where the technology is one side, but again, we need a team of with different background in order to make this possible. And I think the example from all the speakers are in this directions, and including the museum as well. So I want to be positive on this side, that it's something we can do together if there is more. There's a strong consensus on this teamwork.
Thank you very much, Mauricio. Always your point. There is another question from Carlos Andújar. agreed with Gemma that it's necessary to use ITs as support for the cultural heritage experts in the research and translate their knowledge into something worth disseminating. But he points out another question that maybe could be answered by Marco and Jose Luis, because he says that probably he sees as a problem that in the next years, VR and AR technologies, virtual reality and augmented reality, will lose the glamour, the novelty, and the attractiveness, because people will be more used to that. And how can we face the lack of novelty or the lack of fashion of those new technologies from the, so I address it, but any one of you can talk. But I was thinking on Marco as the specialist and Jose Luis as the marketing specialist. How can we face this obsolescence?
Well, the question was if they lose the novelty because they become normal, it means they are normal and people are using them. So at the moment, we are still in a phase where only very enthusiast, very technical enthusiast people have one of these devices and try to use it, because you need specific hardware, you need a specific space also if you want to have an immersive interaction. If the things become so common that it's pretty normal to look through the world through your cell phone or some other device that make possible the augmented reality, will be a good opportunity, not a bad one. We cannot survive only on tech enthusiasts. Especially a museum is not motivated to invest in a virtual application that only 10,000 people in the whole world can experience. If this is a thing that works on most of the available platform, and in this sense, I agree with what Jose was saying before. What are the platforms that are showcasing these kind of technologies? Not many. Not if you want to, if you go to Booking to find a location to rent to have an hotel, not to Expedia, not even completely on Facebook, even though Facebook possess the Oculus technology. So not even there as a platform where you find. A few months ago, I needed to go to Rome. I searched train for Rome, and of course, I had tons of advertisement about Rome on Facebook in the next week. All the advertisements were not focused on virtual activity and this kind of stuff. So there's a lack of support from the platform. If the thing about the virtual and the immersive and the augmented becomes mainstream, then you will have more opportunity and not less. Maybe it will not be cutting edge and you can publish paper out of it. We'll find some other topic to publish paper, but for the actual practical use, I hope that these things become more and more mainstream in order to not having 10 minutes explanation before letting the guy inside an installation that you are creating.
Thank you, Marco. And Jose Luis.
Yes, I absolutely agree with Marco. If the success is supported by the novelty, I think that the future is short for those solutions, at least from a business perspective. So I think that the content that we are creating through the VR and augmented reality release very valuable. Of course, the content is incredible, but as Mauricio said, I think that if we don't integrate that content into a strategy of communication, is very difficult to take advantage of that content. So answering the question, as I said before, okay, I think that really big platforms are not using this. Big distributors are not supporting on these technologies to market their services. So probably customers are not buying per se some product because it's you have this text in them. So if you are just supporting because of the novelty, it's not a lot of future for this.
Well, it's 4 o'clock. We should end at this point. I have to say that I have never seen 6 questions in the Q&A section of the webinar all around the workshop. So it's your merit that you did a very magnificent discussion. Just to comment you, one attendee thought that if it is maybe an unfair competition with the commercial video games like Assassin's Creed that have a very good investment, and other attendee commented that in some exhibition technology or clouds, the real object and the real history that they want to tell, and there is a danger of promoting the technology over the history that you want to tell, for example. And well, and what happens if the expectations exceed the investment? I mean, you may put a lot of expectation, and at the end, the result is quite common. So there are, I mean, yeah, if we may stay here for half an hour more, there will rise probably more and more questions. So finally, I just have to thank all of you, your participation. I think that it has been a great panel. I think that we have put in contact a lot of people around the community, very different point of view. As attendees may see through the YouTube channel and through the attendees list, the attendees to the conference and the video that will be available in YouTube from tomorrow. It is a very intensive session. Thank you very much, all of you, and enjoy, because we have the last session of the conference right now, which is about virtual reality and augmented reality in museums. So thank you very much again, all of you. And you have 1 sentence to close. I give the words in the same order that you started in the beginning. Giorgio, 1 phrase to conclude. 1 sentence.
No, it's important for me use all the new technology to improve the engagement for have more people that can love arts and love culture. And today the technology is ready for this, and so we are here to try to do this. Thank you very much to all, and it was a pleasure to participate to this meeting. Thank you.
You're welcome.
I would say that we have to make this incredible content attractive to our customers and boost these cultural products profits and benefits.
Thank you, Jose Luis. Okay. Mauricio.
I strongly believe in cross-disciplinary and multidisciplinary education. So if we invest correctly there, then I think we have the content we look for, and we can design together the future of the technologies. I don't believe in the separation between humanities, art, science, and so on. This to me is a very old school. If we are on this on the same page, look, like the team we have here. So let's think about this dream team in action somewhere, sometime in the future, and the future generation of students should be in this dimensions, I think, and then we can hopefully have we can design a different future in a way, or in the way we like we discussed today.
Thank you very much for participating, Maurizio. Gemma.
For me, the important thing is also teamwork. Teamwork with the ones we know now and the ones we still don't know, and I'm sure they have to be in the team.
Thank you. And Marco?
We love to use the same data in scientific and diagnostic and in dissemination. This has true potential because a lot of times you see 3D and this digitization as a cost, but if you're able to use it for a technical work and for dissemination, this makes everything more sustainable and more integrated between the two different worlds. And this is another thing that is worth pursuing.
Okay, that's all, folks. Thank you very much again for coming, for making us an enjoyable panel, and hope to see you soon presentially in Italy, in Barcelona, in Rome, in US if possible, Mauricio, in Pisa, and also in Marbella. Have a good evening and enjoy the next session that will be chaired by Selma Trivik, who was the chair of the past GCH conference in Sarajevo last year. Selma, hello.
Hello.
It looks like if we were in Eurovision. Hi, yes. Selma. Greetings from Granada.
3 points.
Thank you.
Okay. Good afternoon to everybody. I'm welcoming you to the session called Virtual Augmented Reality and Museum Applications. And we have here the 4 papers, 4 speakers. And I am now inviting Dennis Henneman to present us the paper entitled Augmented Reality for Sculpture Stability, Analysis and Conservation. Dennis, the floor is yours.
Thank you. I'll just share my screen now. Oops. Sorry, 1 second.
Take your time.
So there's no option to share just part of the screen. That's okay.
Okay. Good. We see you.
There we go. Okay, so does it all look fine to you?
You can go to the presentation mode. It is
shoot.
On the bottom of your screen, there should be an icon.
Sorry, 1 second.
Slowly.
Okay, sorry for the wait. I think it should be working now, right?
That's very nice. Please continue.
Okay. All right. Well, thanks for waiting. So my name is Dennis. I'm a student at Boston University in the US. And I've been working on this project on how to best apply AR to sculpture conservation for the past 1.5 years with the other 4 co-authors of this paper. So in 2006, there was an incident at the Fitzgerald Museum in the UK when a visitor accidentally bumped into a single vase, which then triggered a domino effect that toppled a series of vases that were nearby. And this is just one instance of how the instability of an art piece can cause some serious damage. So our overall goal is to use AR to help museum conservators best predict sculpture damage before it actually happens. And most importantly is to convey that information in a way that's most suited for those who might not have a technical background. So this isn't for an engineer or a computer scientist, but it's for the historians and conservators who are actually making the exhibits come to life. And our application has 4 main parts. The first part is for the user to import the AR model next to the real sculpture in world space. Then a static analysis allows the user to test on sculptures that are fully connected and have a constant density in order to determine all the possible ways that they can possibly tip over. Then a dynamic analysis allows the user to use real-time physical simulation to observe the tipping behavior of more complex sculptures during a user-controlled collapse. And by more complex, that includes sculptures that have widely propagated cracks and stacked segments that could possibly have varying densities. And after the collapse is finished, the user can then look at all the different ways that the sculpture surface has been impacted by the ground impact. So we'll start by going over our methodology and then the software that we use to actually make our application, and then the results of some user studies with actual conservators from the Museum of Fine Arts in Boston, which I'll be calling the MFA. And they gave us some important key pointers for future work, which I'll go into at the end. So we tested our methods mostly on reconstructions of sculptures from the MFA in Boston, which involved a photogrammetry software called Metashape. And so we supplied about 100 images of each sculpture captured from a range of view angles into that software to then make the corresponding 3D model with a high amount of detail and accompanying texture mapping. Then after that process ended, we fed the models into Maya for post-processing, which involved correcting artifacts like holes, taking away excess geometry, and making appropriate separations for widely propagated cracks. To import the model, we require the user to put 2 reference points on the base of the physical sculpture, which gives our application enough information to generate the AR model next to the physical sculpture with matching scale and rotation. And we've chosen to have the testing done in this context because it allows the user to see how the tipping angles and tipping forces on the AR model will translate over onto the actual sculpture that's right next to it. And because it's in an AR context, it gives some important spatial cues for how the potential space of the gallery would impact the possible weaknesses of that sculpture. So jumping into our static method, which is more suited for sculptures that are fully connected and have a constant density, as I mentioned earlier. This method can see all the possible ways that those kind of sculptures can fall over. And before we understand how that works, we need to understand that objects can only tip over by hinging around the edges of their convex hull base, where each edge on the convex hull base will correspond to one unique tipping direction as it acts as the axis of rotation for the overall model during tipping. Furthermore, each edge then has its own critical tipping angle, which is the minimum angle that we must rotate that sculpture around the edge before gravity will start to actually tip it on its own. So if that's hard to understand just from screenshots of the application, here's a more detailed image that shows how this is all being calculated. So we're trying to calculate the critical angle theta I for an edge of interest EI. And our first step is to calculate the center of mass C, which is given here, and then to project that center of mass onto the sculpture base, shown here on the left from a bird's eye view. Then we can form a right triangle between the center of mass C, the edge of interest EI, and the center of mass projected onto the base. And this right triangle will contain theta I, which is the critical angle that we're trying to calculate. And so we use a simple trig function given here on the lower left that allows us to do that pretty quickly. And this process is repeated for each edge on the sculpture base, so we can get all the possible critical angles. We've also made a greedy edge clustering algorithm that can consolidate a sculpture's base geometry in real time. So oftentimes there's a base structure that looks like the one on the left, which even though it's accurate, might have a lot of tipping directions that can overwhelm the user. So we want to keep the overall shape of that base while just keeping the most important tipping arrows. So that's done with an edge clustering algorithm, which you can see here on the right. We'll still keep the overall shape of that base while still making an uncluttered interface. Here's a pretty short demo of a static analysis on a sculpture from the MFA. So we saw here that the user just tapped on this arrow on the base graphic, and that made an opaque copy of our sculpture rotated around that edge by the corresponding tipping angle. So in that way, our opaque copy of this model is showing the exact pose that the sculpture must be in before gravity will begin to topple the sculpture over in the direction that was chosen by the user. Also note how the base graphic will spin to match the user's current perspective of the overall sculpture. Now jumping into our dynamic method, the user first starts by tuning a slider on the left side of the user interface that will rotate the ground in the X direction. And this happens until the point at which the top segment will fall over and hit the ground. So we see on the lower right that happened at an X angle of -13.5, and then the user able to visualize the impact with the ground that top segment had. So here's how we calculate for the current frame whether a sculpture segment has tipped over in the dynamic method. So very simply put, we just compare the up vector of that sculpture segment to the up vector of the ground. And if there is a non-negligible angle, then we know that that sculpture segment has started to tip over because its base can no longer be parallel with the ground plane, as you can see here on the right. And after a sculpture segment has fallen over, to ensure that it collides properly with the ground plane, we give it a collider based on the shape of its convex hull. So even though this boundary isn't exactly mesh tight, it's still just as accurate as a mesh tight boundary, because in this application, the only thing that each sculpture segment can bump into is a flat infinite ground plane. So as these images here are showing, there's no way that any concave portion on the sculpture mesh can possibly touch the ground plane during a collision. So in this way, the optimization lets us calculate the collisions at interactive rates without sacrificing any accuracy of the overall simulation. So to implement our application, we built it on top of Unity, which offers a host of functionality through its physics engine and its rendering engine. And for the core AR functionality, we use ARKit, which makes the application only compatible on an iOS system. Then, as I mentioned earlier, we used Metashape for the photogrammetry and Maya for the post-processing. Throughout the course of our project, we met with conservators at the Boston MFA, who gave us some pretty important feedback on the efficacy and the overall clarity of our techniques. And overall, the feedback was pretty positive. They believe that an application of this kind could possibly supplement current methods by pointing out weaknesses that might not be visually intuitive to the conservators and would prompt them to ask a structural engineer for further help. Whereas this could possibly also be a more important application at a smaller exhibit that lacks the funds to access the same kind of engineers. But that being said, despite the positive feedback, there are still some important drawbacks that we have to mention. So currently we only approximate cracks through each sculpture with a planar slice. And as you can see here on the left, cracks don't always take a perfect planar path. So in this case, our simulation would not attribute accurate volume to each side of the partition. And we also don't yet account for artificial supports that are placed onto the sculpture, such as bolts and armatures. And lastly, I'll just touch on some other areas of future work. So one thing that the conservators actually asked for was to convert our user-controlled ground rotation angles into automated behavior that models things that could actually happen conceptually, like earthquakes. And this would help them more easily understand the information that our app is calculating. And there's also methods that we can add for more advanced ways to predict cracks that might form in the future. So a finite element analysis could analyze how the internal stresses of a sculpture during tipping might cause it to crack in the future. And a fracture analysis method could indicate which cracks are likely to form as the sculpture segments fall to the ground and impact the ground. So that's it. I want to give a special thanks to the conservators that helped us during this project. And thank you all for listening. This is definitely a work in progress, but it was pretty great to share our first milestone with you all. And I can take any questions now during the remaining few minutes.
Thank you very much, Denis. It was very interesting and exciting. I don't see any questions yet, so I will take liberty to ask one. You said that you were testing this application on conservators, but have you been testing it on common users, museum visitors, and what are the opinions of the users?
So you're asking if we've ever tested it with museum visitors?
Yeah.
So not right now. Actually, one of the main reasons why we wanted to look into this kind of application of AR is because we often don't hear about AR being used for the conservator side, for people who are actually making the exhibits come to life. We often hear about AR being used to make the museum experience more vibrant for those who are visiting. So no, we haven't done that yet, but that could definitely be of interest in the future.
Yeah, thank you very much. I think it will be very exciting for the visitors. We have one question saying, does the program consider the internal composition of the sculpture, e.g. whether the sculpture is hollow on the inside?
So not currently, and that's a pretty big drawback, definitely. But you know, that's an area of future work. We currently assume for the static method that there is a constant density, but for the dynamic method, we can have some more complex cases. So if somehow with a method that isn't a photogrammetry process can create the geometry of a hollow sculpture, then that would potentially work in both of our methods. But currently, since we're using a photogrammetry method, that's hard to do for the interior composition of a sculpture.
And now you can stop sharing your screen and we will move to the next presenter. And the next presentation should be of the paper called Ernst Grube, a contemporary witness through a contemporary witness and his memory is preserved with volumetric video. And we have Markus. Markus, could you please share your screen and introduce yourself and start presenting?
Yeah, sure. I hope it's visible to everyone.
It is visible. Please proceed.
Great. Thank you very much for the introduction, and good afternoon, everybody. And welcome to the presentation of our short paper. My name is Markus, and I'm a research associate at Fraunhofer HHI in Berlin, Germany. And this work was done in a joint project with UFA GmbH, so I would like to thank them and also my co-authors at this point. In recent years, XR technologies like augmented reality and virtual reality created new ways for media consumption. And especially virtual reality can offer immersive and very authentic experiences. In cultural heritage, we can use these immersive technologies to keep the history alive for future generations. And we think that one specifically interesting and lively approach is retelling stories and memories of individuals. And this thought leads to the insight that a person who experienced a story is itself part of history. I mean, it would be incredible if we could preserve persons and re-experience their presence even long after they are gone. But the question is, how can we capture and present humans realistically in computer graphics? And one solution to this is volumetric video, where a person is recorded in a special volumetric capture studio, which allows obtaining a dynamic 3D reconstruction of it. And this representation can then be integrated into arbitrary virtual worlds. All of these previous ideas and concepts are combined in the virtual reality documentary Ernst Grube, The Legacy. And its general idea is to preserve the stories of the Holocaust survivor Ernst Grube in the most immersive and interactive way. And for this documentary, the contemporary witness was was interviewed about his life in Nazi Germany and after the Second World War in such a volumetric capture studio. Additionally, historical sites that matched the interview content were recreated by artists. And the documentary then combines both the modeled and reconstructed content and can be freely experienced by viewers in VR. So that means viewers can move freely around in the environment and also around the protagonists while listening to the interviews. Our work focuses more on the technical side of this documentary and in particular on the volumetric reconstruction pipeline of the capture system. The system is called 3D Human Body Reconstruction, or in short 3D HBR, and it was previously used for other volumetric video productions. So it's kind of established already. And the system uses 32 high-resolution cameras, which are arranged in 16 stereo pairs to capture 360-degree videos of persons in this cylindrical studio you see on the left side. The actual reconstruction is performed frame by frame and starts by computing 16 depth maps, so that means one for each stereo pair, which are then fused into an oriented point cloud. From this point cloud, a triangle mesh is recovered and simplified to the desired level of detail. As you can imagine, for example, the triangle count for mobile applications is typically less than for desktop applications. In order to get some temporal consistency between the frames, the meshes are then registered to temporal neighbors in the sequence. And finally, the meshes are textured by projecting the camera images onto them. And since we have a very diffuse lighting system in this studio, it makes it possible to relight these meshes afterwards. An important question is, why do we need to bother with this pipeline at all if it's established and has been used for other projects? And we find this answer by looking at this volumetric asset that was produced by the pipeline, with the pipeline by previous work. And the quality may be enough for experiences which do not focus primarily on the protagonists, but it's certainly not enough for cultural heritage and also not for our historical context. For example, see details like the finger or the faces, which are not accurately reproduced. We took a step back and investigated the pipeline and the data, and we found some parts that cause issues or are not correctly handled. First, the two-person scenario is something new to the pipeline. That means previous productions included one person and maybe a few small props at most. Due to the interview setup, the protagonists stand very far away from some of the cameras, and especially those that see their front sides. So this means that reconstruction errors in important regions like their faces become more likely. And lastly, is it still working? Yeah, okay. And lastly, lighting errors in the captured footage cause the foreground segmentation to fail occasionally. That means we have to cope with very noisy masks. If you look at the feed, for example, you see that these masks are pretty noisy. And we use these insights to adapt the reconstruction pipeline in this context. The first part that we revised is depth estimation. On the left side, you can see the baseline 3D HBR depth estimation in action for some stereo views. And these views are pretty challenging, and the depth estimation has a hard time finding reasonable depth for both protagonists, even after as many as 30 frames from the start of the sequence. And the issue here is that the depth estimation algorithm that is used needs a very good initial guess, but the initialization procedure of 3D HBR assumes a single object, small occlusions, and clean foreground masks, which is obviously not given in this context. Instead, we drop these assumptions and use an initialization based on feature points. Basically, we detect and match feature points in both stereo images, triangulate them to get their depths, and use these depths as initial values for nearby pixels. And we found that this small change leads to significantly improved convergence at the start of the sequence. So with this approach, we now only require one frame for reasonable depth estimates. And this approach might also help to better handle sudden visibility changes, since the problem is very similar to the one seen here. The second part that we revise is depth map fusion. Again, the baseline 3D HBR results are on the left. The used algorithm combines multiple depth maps into one point cloud by selecting certain patches from the depth maps and just projecting them into 3D space. And since it does not do any averaging, it kind of relies on accurate input with little noise. However, as I mentioned before, the distance to the cameras will introduce noise in the reconstructed depth maps. So this approach is not really able to fuse them into one coherent surface. We replace the fusion by an approach that uses truncated signed distance functions and multiple point cloud cleaning stages. We first merge all the depth maps into a discrete truncated signed distance function and extract the point cloud from it by finding zero crossings on its grid. We then remove artifacts outside of the objects with visual hull-like constraints and bounding volume clipping, and artifacts inside of the objects with occlusion cleaning. And we found that the point clouds produced by our depth map fusion have less surface noise and reproduce details more faithfully. Now with the revised pipeline, we took the same data and generated our version of the volumetric asset seen before, and this video shows the final result. As you can see, the volumetric video captures the appearance of both the interviewer and Ernst Gruber very accurately. And even fine details like fingers are reconstructed. And also, it's not really part of our revision. I also want to highlight the temporal stability of the geometry and texture. Integrating the volumetric video asset with other computer-generated content is actually pretty simple, since we can encode the mesh sequence as MP4 file and import it into engines like Unity using a custom plugin. Actually, the player you see in this video is implemented in Unity. On this slide, we can see the volumetric asset integrated into its designated virtual scene, and it's actually the first real impression of the documentary, or more specifically, one of its episodes. In this episode, Ernst Gruber shares stories of his early life in Nazi Germany, and the scene shows him in the garden of the children's home in which he spent parts of his childhood. This episode will also be part of a proof of concept experience that is presented at the memorial site Sachsenhausen in Germany, which is basically intended to determine how this kind of storytelling is perceived by the general public, and of course to generate some interest in this technology. Unfortunately, we cannot yet show moving content or live demonstration of this experience, but the preview images show that our virtual protagonists convincingly portray their real counterparts and also blend well with the general scene and surroundings. We think that the quality of our assets is now at a level that will really push and help this documentary to be as immersive as possible. So let's sum up the most important points. As we've seen, the context of our work is an immersive VR documentary about the Holocaust survivor Ernst Gruber, who is integrated into this virtual experience with volumetric video. This use case needs volumetric reconstruction that is very accurately and captures the persons involved with all the details. And in order to reach this quality, we investigated challenges in the setup and data and improved parts of the reconstruction pipeline. We then integrated a high-quality volumetric asset from this pipeline into a virtual scene, which is the first preview of one of the documentary's episodes. We think that this preview looks very promising, and the increased quality will be a key component for the documentary's further development and also the success. I want to thank all the attendees for the attention and also the organizers of this conference.
Thank you, Markus, very much. This was very, very interesting, especially for me, because we have been experimenting with 360 video and the combination of live actors in the virtual environment. So for me, it was personally very, very interesting. As I don't see any questions yet in the questions and answers, I will again take liberty to ask you a question. What about the shadows? When you do you generate shadows artificially in Unity, or what to do with them?
That is a good question. Actually, the lighting set of our studio produces a very diffuse lighting. So that means when we have the models or the meshes textured, they don't really have any lighting baked in. So that means we can use artificial lights like point lights or directional lights in Unity directly and then relight the meshes. So we can completely integrate them into the virtual worlds. So we don't need to, basically we don't need to bake the light situation into the models.
I see. Okay, thank you very much, Markus. This was a very interesting presentation, and we don't have any more questions. So now I would like to invite the next presenter.
Thank you.
And thank you. And the next paper is called Archaeopuzzle, an educational game using natural user interface for historical artifacts. And I would like to ask Nicola to start sharing his screen and to take the floor to present the paper.
You hear me?
Yes. We hear you and see you.
You see my screen?
Not yet, but we see you.
No?
Not yet.
No?
No.
Just a moment.
Now it's coming. Okay. Yes, we just need the presentation mode because now we have the.
Okay.
That's it. We have your full screen. You can start.
Okay. Can I start?
Yes, please.
Okay. Good afternoon. I'm Nicola Capece, a research fellow at the University of Basilicata. Today I will speak about Archaeopuzzle, an educational game using natural user interface for historical artifacts. The talk is divided in the following way. In the first part, I will give a brief introduction of the application context. Then I will show some related work and the technologies used in the proposed work. Then I will show our system, and finally I will talk about possible future works and conclusions. 3D visualization of historical artifacts find use in a lot of application context. For instance, a virtual museum, archaeological excavation, virtual reconstruction, and so on. A large specific field of use refers to the exploration of cultural heritage through computer graphics and visualization tool. As a virtual heritage provides information and feedback on the past ages visualization, human-computer interaction could increase the learnability of such information. For these reasons, we investigated a game learning approach to visualize, navigate, and interact with 3D reconstructions of historical artifacts through natural user interface and 3D visualization. In particular, we propose a serious game called Archaeopuzzle, which main challenge for the gamer is to reconstruct ancient objects appearing from fragments scattered in the scene using his hands tracked from lip motion controller. The aim is to imprint the physical features of ancient objects represented by 3D models in user minds to facilitate their understanding. The principal advantage of our approach is to ensure the user to learn in a protected environment, and he can be actively involved through his hands interaction, which should increase the learning factor respect to the classic teaching approach based on the frontal lesson, also called passive learning. Human-computer interaction 3D visualization were primarily used in the last years for the educational context. This is a short overview of the related work. Some of them also use augmented virtual reality mixed with human-computer interaction to increase understanding of cultural contents. The proposed game application is a desktop-based application, and it has to use the lip motion controller.
placed on a table with the user in front of the screen. The system presents the 3D reconstruction of the historical artifact, reduced into multiple fragments scattered around the scene. Such a system was developed with the Unity 3D game engine. The scene was structured as a specific and well-defined space that can be viewed from multiple points of view. Objects were placed in the foreground, and the scene was adapted to the user's simulation to create a virtual environment suitable for the type of simulation offered. In the center of the scene was placed the object to be reconstructed, and the camera looking at the object and rotating around it. The gravity physical property was applied to the fragments, and the scene was limited by colliders that prevent the fragments from going out to the simulation environment limits. At this step, to develop our application, we used the two 3D models, an ancient terracotta amphora and a Venus de Milo statue, but in general, any object could be viewed. To divide the 3D historical artifacts, we used a 3D Studio Max script called the Fracture, based on Voronoi fragmentation approach. Through this script, the fragments are generated randomly by providing the number of them, of the fragments. The fragments are consistent with each other in terms of spatial dimension and the number of polygons. And each of them is considered as a submesh of the main object and a child in the 3D model in a 3D prefab Unity on Unity 3D hierarchy. We used a grid model-based system where each grid space is represented through the fragment, the shaped box collider, as a boundary within to place its mesh. The idea is similar to the data structure in which each grid space represents a map placeholder, and each fragment is a key of its map placeholder. When the fragment object is imported in the scene, a ghost copy without a render component is created. If the user moves a grabbed fragment and reaches the main 3D object area, then a placeholder of the ghost copy becomes opaque in order to simplify the puzzle construction. The box collider of the map placeholders have the trigger components enabled, which are useful for signaling when a fragment is approaching a grid space and assessing if it is the correct one for such fragment. Fragments have also the box collider enabled that interact with the map placeholder box collider to allow reconstructing the main model as a 3D puzzle. When a fragment approaches the map placeholder area, the latter checks if the fragment has the correct key. If so, the system measures the orientation precision of the grasped fragment respect to the approached placeholder area through the scalar product. When the 90% of orientation precision was achieved, the system simulated the fragment gluing in its final location. The user can grab the fragment using his hands, tracked with the rip motion controller. To grab the fragment, we used the pinch gesture. If the user is an expert, he can use two hands to grab the fragment together. Two fragments together. This is a short video that shows the reconstruction of the of two 3D models. The first one is terracotta amphora, and the second one is Venus de Milo statue. When the system is started, the scene is empty and all of the working area is visible. When user is ready to start, he selects the first historical artifacts to reconstruct by choosing it from a well-defined menu using the keyboard. In this example, a terracotta amphora was divided in 10 pieces, and the Venus de Milo statue was divided in 40 pieces. When the main object is loaded, the system randomly places its fragment within the scene using a displacement vector, simulating a controlled explosion so that fragments remain in the working area. The fragments have the gravity physical property enabled until it gets close enough to its correct position. In this way, the reconstruction of the 3D model typically becomes more easy for the user to perform. In addition to the pinch, we implemented a helping gesture to guide the user with little fragments to scatter in the scene. It consists of approaching the two hand palm together in front of each other. The fragments are brought closer to the work area, allowing a faster grip by the user pinch gesture. In the future, to make this system accessible to anyone, we would like to investigate the replacement of a specific device, such as the leap motion controller, with a simple RGB camera, using hand tracking approaches, for example, with technique based on deep learning. The next step consists of a controlled experiment through the contribution of archaeology students. As a first phase, the idea is to evaluate the usability, user experience of the system, and sentiment and thinking of the users during the gameplay. In a second phase, we will assess the effectiveness of the serious game for the learning proposal. We would like to perform the experiment with support of archaeology and cultural heritage experts that provides a specific questionnaire to the participant focused on the historical artifacts, feature, and content and the context. To achieve these results, we will develop a series of tasks where the 3D puzzle reconstruction gradually increase of difficulty, starting from a simple model and finishing with the complex models and with an incremental number of fragments based on the difficulty level of the game reached. To conclude, this work shows a natural user interface based on the leap motion controller and the Unity 3D game engine for the simulation of a serious game based on a 3D puzzle. The main idea is to provide an archaeological tool that is fun and engaging. Such tool could be useful within a museum, for example, to resemble ancient objects often inaccessible in the real world. Thank you. Thank you for your attention.
Thank you very much, Nicola. It was very interesting. And I see one question. So Munisa says, very nice work, and she has two questions. First is there a dashboard to add more artifacts, or every time the artifact has to be included manually, in case the museum would like to have this game for their particular artifact collections? And the second question is, what method do you use to measure the usability and sentiments?
Okay, I answered first the second question. For the second question, we want to use the system usability score questionnaire to measure the usability, and the self-assessment mannequin questionnaire that are the state of the art in the literature for the measure the sentiment, the thinking, and the SAS is useful for the user experience. For the first question, the dashboard have such artifacts, and the museum can personalize the scene aspect based on its scope, learning scope. Okay.
Thank you very much. I also have a question. You said that you want to offer some educational dimension also with the game. So what kind of educational data you have in mind, and how you will present them to the users?
Okay, I'm not expert on the cultural heritage or archaeologically field, but we would the learning effect is to understand the physical characteristic of the 3D model. For example, if a 3D model are not accessible in the museum, the system can show us such 3D object as such 3D rare archaeological artifacts are composed, are formed.
Yeah, maybe you can add some story about the artifact or some intro about the context or something that would also make people learn about the importance, historical importance. Of course, you have to do it with the museum people and the consultants from the field. Okay, thank you very much, Nicola. And last but not least, we have Andrea and Louise. And Andrea will present the paper entitled V Horus Project, a virtual reality experience to preserve the Egyptian collection of the National Museum of Brazil in Rio de Janeiro. And Louise will join for question and answers. Andrea, the floor is yours.
Okay, thank you very much. It's a pleasure to speak here today. So I'm going to share the screen. They say here that I can't share because the other one is sharing.
Okay, I don't know who is sharing, but let me check what's happening. A second. Okay, Nicola is still sharing the screen, so I will stop his sharing. Okay, try now.
Okay. Okay.
Okay, that's
here,
good.
Now you see? Okay,
yes, we do.
Full screen. Okay. So, good afternoon, everyone. The project is V Horus, as you presented, a virtual reality experience to preserve the Egyptian collection of the National Museum in Rio de Janeiro. The National Museum is the most important and oldest museum of natural history and anthropology in Brazil. Its Egyptian collection was considered the largest in Latin America. Sorry, okay. Unfortunately, in September 2018, a big fire destroyed most of its collections and included many of the Egyptian artifacts. So since 2003, the National Museum, in partnership with other Brazilian institutions, had a project to digitalize artifacts for analysis and preservation purposes. After the fire, these scanned images of this project represented the possibility to continue scientific research and also allowing faithful digital reconstruction of the artifacts. So from this possibility came the idea of an interdisciplinary project, the V Horus, which has the objective is the digital reconstruction of the destroyed artifacts of the collection, and it's a collaborative work between 4 institutions. I'm just present myself before, sorry, I am a researcher of PUC-Rio. And so these 4 institutions work collaborative in this project, and 12 researchers were involved. So here you can see the presentation, which is a visible, tangible experience realized on site for the public. And relating to the artifact selection, considering the importance of the mummies in the museum collection, it was decided that the experiment would be the reconstruction of the Roman mummy. This selection was motivated by the unique mummification process in which each part of the body is wrapped separately, and also because of the vast photographic documentation and previous research information about the piece. So here you can see the Roman mummy, and the CT scan image analysis showed that this mummy was of a young woman between 15 and 18 years old, who probably lived at the time when Egypt was under the rule of Rome, in the 1st century after Christ. There are also studies that suggest similarities between the mummification process of Thor with other mummies exhibited in European museums. This is in France, this train in the History Museum in Holland, and this in UK in the World Museum. So here we can see the CT scan example from which a 3D model referring to the surface of the artifact was extracted from the tomography volume. Then a fast prototype of the model was created and submitted to the evaluation of the curator of the collection and the bioarchaeologist who was the coordinator of the SCAN project I mentioned before. The whole process was recorded, and its analysis directed choices made for the experience development. First, the need of precision in the characteristics of the artifact, in the representation of materials, and on the 3D model. Second, the user's perception of detail was fundamental for the experience success. Okay. So here in summary, the process, okay? In summary, the model creation was carried out in 3 stages. First, obtaining the model surface from CT scan volumetric data. Then the model retouch and optimization in geometric mesh. Then we have a manual composition of textures from details of photographic images and the artifacts and other materials, and the application on the surface of the model. In this way, we sought to give the model a texture that reacts, as you can see here, to the projection of light and the movement of the eye using PBR. So the VR experience objective was to build an attractive narrative to engage the audience. So the narration, the music, and the 3D model of the mummy were imported into the Unit game engine. Here you can see the frames from the experience and observe that the lighting was designed to highlight the main aspects of the mummy mentioned in the narration, and also the lights was guided to guide the user. The soundtrack was selected from Egyptian songs, and intentionally no 3D scenario was built. In this first experiment, the user can explore freely the virtual environment, walking around the mummy. And but there is no active interaction between the user and the experience. And this will probably include in the next version. So then you have 2 exhibitions, one in the National Museum, when the VR experience was exhibited for the public in 2 events, as I said before. The first event was the 7th seminar on Egyptology on the National Museum. And the second one is the Design Week at the Pulchihri University. The setup of the experience includes the table, and which function as a physical tactile reference in the virtual environment. Tangibility and great realism were being tested as elements to bridge the gap between the physical and virtual space. Then you have user evaluation, and you have 18 survey and 18 closed questions, and a total of 153 people answered the survey immediately after viewing the VR experience using a mobile application. The survey was composed by, as I said, 18 questions, distributed among multiple choice, 5-item linked type scale, and open questions. These answers showed that the National Museum group was formed mostly by museum professionals who knew more about the artifacts, but has less extensive experience with virtual reality. Also, the average age was higher. The university group was formed on average by younger people with more previous experience with VR, but less knowledge about archaeology. So, although evaluation about the experience, although the samples have different profiles in terms of age and familiarity with VR, the participants' involvement in the experience in the 2 exhibits proved to be very similar. They both, more than 90%, found the experience engaging, feeling of seeing the moment itself, thought that the light helped them to guide their attention, and the narration and music contribute to the immersion and involvement with the experience. So regarding the user's perception and credibility of the experience, the quality of the artifact, the tactile stimulus realized by the possibility of touching the table using the physical environment contributed to the credibility of the experience. The sharpness of details and the possibility for the participants to get closer to details, more close than usually in the museum, contributed also to see details barely visible in the real form. Regarding the perception of the VR technology, the majority would like to see other objects from the collection, said also that the VR can contribute to the democratization of knowledge, and thought VR is a more realistic and pleasure way to visit a virtual museum than see on a desktop. Only 5% of the public reported discomfort. Conclusions. The importance of collection digitalization is very important, the collection of digitalization, and this would be very important to work in multidisciplinary teams and needs sometimes collaborative projects between institutions. Also, it's important to have a continuous development on the digitalization process. The process using the VR project creates an engaging experience, sparkle public interest in see other artifacts from the collection lost in the fire. About the methodology, it's proved to be scalable and adapted to other artifacts of the National Museum, and can serve also as a guideline for other institutions that may suffer the same problem, loss due to wars, fires, or other causes. So if you have any other information, please access the website of our project. The address is here. And with this, thank you very much for the speaking here.
Thank you very much, Andrea. And if you have any questions, people, you can write in the questions and answers. And I have a question, actually. I was watching your user evaluation, and you said that a small number of participants reported some discomfort. So I would like to know what kind of discomfort they reported.
Okay, only 5%, what I consider very low, but they are more related to the use of the VR equipment, not about the narration. Only one person talked about the narration because it was starting on the dark, and the person was a bit frightened, but only one in 153. So
yes, exactly. That was my question, because of course the discomfort was related with the equipment, and my group is also experimenting with VR. So for some users had motion sickness, for example, in our cases. So that's why I'm interested to know if somebody reports.
No, no one reported sickness. They were like, because how to fix the Oculus, the VR Oculus. That was the main question, the main issue.
Okay. And do you have any interaction with the artifact in the application?
Yeah, not in this version. You could work around and get very close and see details. But it's one thing that we are trying to work to the next version. This is in our mind, I'd like to see the interior, and if you can touch some options, we are working on that.
Okay, we have a question from Luis Almeida. For how long, in average, were the users wearing the VR headset? The 5% discomfort is a bit surprising.
Oh, okay, 5 minutes. The experience was less than 5 minutes, like to be exactly 3 minutes and 50 seconds.
Yeah, wow.
But I don't know if we had only one Oculus, so perhaps because of a lot of people were using a short period of time, perhaps this happened because of that. I don't know. It's our thing. Yeah.
And in any case, the experience shows that these applications cannot last too long, because then people show some discomfort after 10 minutes, let's say, or 15. Okay. Thank you very much, Andrea, and thanks also to Louise to be available for the questions. And I would like now to end this session and give the floor to Javier. Thanks to all the speakers.
Thank you very much.
Thank you very much for the panelists. And now, after a lot of months of hard work, it looks that the end is coming. I will pass the words to Michela as co-chair of the program committee, so she will do a resume and announce some important things that we have to say. And
thank you.
Karina is also here. So.
Karina is here. Very
Yes,
good.
enter. Please, Karina, show up. You will participate.
So let's.
Please, Michela, yes.
Okay, I will start with something that is.
It's shown.
No. Do you see the slides?
Yes.
I didn't put it in a. Oh, wait. Okay.
Yes.
Is it better now?
Yes, because I only see you.
That's great. Let me try again, because I moved the presentation. Let me stop the sharing.
No, you are not sharing.
Okay. First here, and now let me share this.
The attendees, I have to say that today we have on average 60, 70 people connected to the conference. Yesterday there were 80, 90, and in total more than 100 people connected at any time in the conference. So I think that it has been very successful. And now there are 60 people waiting for the prizes. So.
And for the prizes, I hope you were not too quick in reading the slide before. So first of all, I would like really to thank, before the announcement, I would really like to thank again Javier, Karina, and Carlos, because really they made a lot of efforts to organize the whole workshop. Concerning now the Best Paper Award, we asked the support of some of the IPC members, helping us in the selection of the papers. The selection has been done taking into account the comments that we received on the technical content by the reviewers during the selection process, the submission process. But we also considered the presentation that was given yesterday and today. So altogether, we selected 3 papers as the best papers that are going to be invited to submit extended versions of their contribution to JOC. And these papers are, here. So one is segmentation-based, the nearly lossless compression of multi-view cultural heritage image data. Do you see them?
Not yet. You have started to the share screen, but it is blank. Blank screen. This makes things more nervous to people.
Yeah, that's good. That's good. Let's see if this works better.
Yes, your email.
No.
Yeah. More thrilling than the Oscars. says Gabriele Guidi. Now, yes, there we can
Good.
see the best paper award slide.
I made
Invited.
Okay, so the 3 papers invited now, you can see them?
Yes.
Oh, okay. Sorry for the mess. So the 3 papers are those that you see. So segmentation-based nearly lossless compression of multi-view cultural heritage image data. Another brick in the wall, improving assisted semantic segmentation of masonry walls, and anatomy changes and virtual restoration of state use. So these 3 are the papers that will be invited to submit extended and revised version to the JOC journal. And among these 3, we agreed on selecting as appointing as best paper the paper Another Brick in the Wall, Improving Assisted Semantic Segmentation of Masonry Structures. And our compliment to the authors. The reason for this is that we all appreciated really the completeness of the approach proposed and the integration of artificial intelligence, image processing, and for the documentation of the whole analysis process. So very, very nice piece of work. And we appreciated also the fact that the code is available online. So our best wishes to the winners of the award. And after this, I will stop this crazy sharing from my side.
Yes.
And hand over to Karina if she wants to say something about the future of graphics and cultural heritage in terms of next event.
Thank you, Michaela. So yes, just to give you an update. First of all, I would like to thank again all the organizers for this excellent event. I must say a few weeks ago, we were not so sure whether we will be able to go ahead, and I'm really pleased about how everything went. And I was really pleased to see people that I would normally bump into at the conference every year, and you see people that have come online and meet virtually, even if only virtually is possible. Now, apart from thanking all the people who have organized, both what you see online, but also people that are helping Javier, I guess, at his university, I would like to maybe give you some kind of outlook. We are still deciding for next year whether the event will take place virtually or physically. So we were not able to kind of decide at this stage whether we will have a completely online event, because we are aware that by the end of next year, it might just be possible, might just be possible that we'll be allowed to travel. So we will disseminate news as soon as we can. Yeah, so we are at the moment trying to advertise for an online event with the potential that we might just make that a physical event. So just look out there for look out there for news. We will open the call for papers next year. And I really hope we are able to meet in 2021. Thank you. Thank you, Michaela. Thank you, Javier.
Thank you. Well, Carlos, you told me that you were not very good. You want to say something as
No.
spectator, participant, attendee, chair, whatever?
So no, well, I just wanted to say that I hope everyone enjoyed the conference. Of course, it's not the same as a face-to-face conference, but my perception is that everything. So it was a successful workshop. So thanks, Michaela, Javier, and Karina for all this. And I would like to say that we will leave the Discord server open for some weeks, right, Javier? So that people, attendees, will have the opportunity to still have follow-up discussions, and that's all from my side. So thank you all.
Okay. I only have to say thank you to Michaela, thank you to Carlos, to Karina, also to Pablo, who is a colleague from my department. He is there. Pablo, show up. He has been also behind the curtains trying to have a backup of if anything fails. So thank you very much. We share now 2 experiences, computer graphics course and a conference. Thank you, the University of Granada, for the sponsoring and the support for this platform that make things easier, and also to the Spanish chapter of Eurographics that helped us with some sponsoring also. For me, my first conference was a past Graphics and Cultural Heritage event in 2003, in the first edition. So, well, I'm glad to be here always, and hope to see you physically very soon somewhere in the world, all of you. And thank you again for participating, for all your help, and hope that 2021 will be a much better year, and we will meet in some places. Okay, thank you all of you. And the videos will be available on YouTube for a while. So if you want to recommend it to anyone, just see. As you couldn't visit the Alhambra in this conference, I just put it in the background for a little bit, and just remember that we have here a wonderful place to visit at any time. If you want to come, just ask for an Erasmus exchange week. Bye-bye.
Bye-bye to everyone.
Bye-bye.